Hello, and welcome to The Sleepy Scientist. This is your time to settle in, get comfortable, and let the day drift softly away. Tonight's journey will take us into the fiery heart of the Earth, where volcanoes, strange, restless mountains of fire and stone, accidentally built the world we live on. Before we begin, I would love to know where you are listening from. It's always a quiet delight to imagine these words being carried across oceans, mountains, and cities, reaching people in so many different corners of the world. If you enjoy these calming explorations, a gentle like and a subscription would mean a lot. And to those who are already subscribed, thank you sincerely for being part of this little constellation of curious minds. And don't worry, I'll try not to make this video so interesting that it keeps you awake, but if it does, at least you'll drift off with a head full of lava, ash, and the quiet wonders of how fire shaped everything you know. There are worse things to dream about than volcanoes that made oceans, skies, and even life itself. So how exactly did mountains of fire born from chaos end up giving us the calm blue world we call home? Volcanoes may seem like sudden, violent events, but in truth they are patient artists of the Earth. Long before forests, oceans, or creatures ever stirred, they were building the foundations of the planet. Without them, there would be no continents to walk on, no seas to sail, no air to breathe. They are the world's quiet architects, shaping landscapes in ways we rarely notice, until they remind us with a sudden plume of smoke or a river of molten rock. This journey will trace their story across deep time. We will walk the shores of newborn oceans that once boiled with volcanic steam. We will wander ancient landscapes of fire and ash, and peer into the deep-sea vents where life itself may have first awoken. Volcanoes carved mountains, spread fertile soils, and accidentally wrote chapters of history by feeding civilizations and at times sweeping them away. But the influence of volcanoes reaches even further. They are not just local events. They are planetary forces. They have sculpted climates, created islands, and in moments of fury reshape the course of evolution. Even myths and gods have their roots in these fire mountains, echoing across cultures as symbols of power, destruction, and rebirth. Tonight, we will follow their trail from the dawn of Earth to the present day and beyond to the volcanoes of other worlds. Each eruption, each plume of ash, is part of a grander story. A story of a planet forever in motion, forever building and rebuilding itself. So as you drift deeper into this calm exploration, imagine the world beneath your feet as alive and restless, quietly humming with the same fire that has always been there. And let yourself wonder, if volcanoes built the world by accident, what other surprises lie hidden in the heart of our planet? In the beginning, Earth was anything but calm. Picture a young planet spinning beneath a newborn sun, not the quiet blue marble we see today, but a seething sphere of molten rock. For millions of years after its formation, Earth was cloaked in fire and fury, a glowing ball wrapped in oceans of magma. It was a place where stone flowed like water, and the very air shimmered with heat. Volcanoes were not the occasional visitors they are now. They were the permanent rulers of the landscape, bursting and billowing from every crack and seam of the restless surface. This fiery childhood was not a mistake or a catastrophe. It was a necessary beginning. Earth was born from collisions, countless pieces of rock and ice smashing together in the crowded nursery of the solar system. Each impact released unimaginable energy, heating the young world until it melted from the inside out. Heavy elements like iron and nickel sank downwards, forming a core while lighter materials floated upward, becoming the crust and mantle. And in that process, volcanoes became the natural release valves, venting heat, gases, and molten rock as the planet tried to find some kind of balance. To stand on the early Earth would have been impossible. The air was thick with choking gases, the ground forever trembling with eruptions, and rivers of lava snaked across landscapes that never stayed the same for long. Yet this was creation in motion. Without these violent beginnings, there would be no solid ground to stand on today. No continents, no mountains, no gentle valleys. Volcanoes were the hands that shaped the clay of a raw, unfinished planet. As the surface cooled, crust began to harden, though it was fragile and easily broken. Beneath it, the mantle churned with heat, restless and convecting. When cracks appeared, molten rock surged upward in fiery fountains, spreading new crust and erasing old. Entire ranges of volcanoes grew and collapsed in cycles of destruction and renewal. The Earth was endlessly remaking itself, like an artist never satisfied with the first attempt at a sculpture. This was also the time when gases trapped deep within the Earth began to escape. Every eruption sent carbon dioxide, nitrogen and water vapour billowing skyward. To us those gases might sound dangerous, but to a barren planet they were the beginnings of atmosphere. Clouds formed, storms raged, and eventually, as the heat subsided, water condensed and rain fell for the first time. The seas that now cover most of the Earth owe their existence to volcanic breath. It is a strange thought. The same explosions we view as destructive today once provided the essential ingredients for life. Without volcanic outpourings of water vapour, there may have been no oceans. Without the steady release of carbon dioxide, the atmosphere might never have thickened enough to trap warmth from the sun. Even nitrogen, so common that we barely notice it, came bubbling from the planet's fiery heart through volcanic vents. What we call a stable environment was born in an age of fire. Imagine the sight. A sky turned orange with ash and steam, lightning crackling within towering plumes that reached higher than any mountain. The ground itself glowed red in places, fissures yawning open as rivers of lava spread outward. Entire landscapes would have changed in hours, mountains rising and collapsing in the same breath. To any observer, it would have seemed like chaos without end, and yet within that chaos, a pattern was taking shape. Land was accumulating, oceans were forming, and the planet was settling into a rhythm. The moon too played its part. It was born from a colossal collision between Earth and a Mars-sized body. The debris coalesced into a companion that still orbits us today. That event alone would have sent oceans of magma surging across the young Earth's surface, fueling eruptions beyond imagining. The moon's pull also began to stir tides in the seas that would later appear, further shaping the dynamic face of the planet. Volcanoes were not working alone. They were part of a cosmic partnership between Earth and its closest neighbour. Over millions of years, the fiery storms eased. The crust thickened, the mantle settled into its deep, slow churn, and the first hints of stability appeared. But even as the surface cooled, volcanoes remained, punctuating the silence with explosions of light and fire. They were no longer constant, but they were always present, as if to remind the planet of its origins. The legacy of this time can still be found in the rocks beneath our feet. Ancient lava flows, hardened into dark basalt, hold the memory of those early eruptions. Minerals forged in the heat of a magma ocean are scattered across the continents, clues to the planet's fiery youth. Even the air we breathe carries whispers of volcanic exhalations from billions of years ago. We live surrounded by reminders of that age of fire, though we rarely notice them. It can be easy to think of volcanoes only as destructive forces, as threats to towns and cities, or as dramatic spectacles captured on camera. But their role in shaping Earth runs deeper. They built the crust, released the oceans, and filled the skies with the air that would one day sustain life. Without them, our planet might still be a barren rock, silent and lifeless. Volcanoes gave Earth its identity, sometimes violently, sometimes quietly, but always with purpose, even if by accident. And so, the story of Earth begins not with calm but with fire, a young planet, restless and molten, finding its shape through endless eruptions. The foundations of continents, the first seas, and the earliest skies were all gifts of this fiery beginning. From the chaos of molten rock and choking gas emerged the possibility of something gentler, a planet capable of supporting forests, oceans, and eventually the creatures who would one day look back and marvel at their fiery origins. In the end, volcanoes were not just a feature of the young Earth, they were the young Earth. Their eruptions were its voice, their lava its lifeblood, and their gases its first breath. They did not know they were building a home, but that is exactly what they were doing. And in the quiet world we inhabit now, it is easy to forget that beneath the cool crust, the same fire still stirs, waiting, reminding us that the story of Earth is, at its core, a story written in fire. The oceans that now stretch endlessly across our planet began not with a gentle rainfall, but with steam rising from fire. When Earth was young, volcanoes breathed heavily, releasing plumes of vapour into the hostile skies. These were not the small clouds we see drifting lazily on a summer afternoon, but colossal billows of steam and gas pouring from fractures in the planet's crust. Each eruption, each exhalation, sent more water vapour upward, where it lingered in a thick, hazy atmosphere. In time, what had once been a world of stone and fire began preparing to cradle seas. The process was far from quick. For millions of years, the air above Earth was saturated with steam, held captive by the planet's intense heat. It was not yet cool enough for liquid water to fall and gather. Imagine a world where the sky shimmered constantly, heavy with moisture, where every horizon was blurred by haze and storms of gas. Volcanoes continued their tireless work, adding more vapour, as if the planet itself was exhaling oceans it had swallowed long ago. At last, Earth cooled just enough for condensation to begin. The first drops of rain fell on still molten plains, hissing and vanishing in an instant. Then came more, until the skies opened fully. For thousands upon thousands of years it rained without pause, not in the way we imagine a storm, but as a relentless downpour that filled basins and carved channels. Where once there had been rivers of lava, there were now rivers of water, pooling, joining, and spreading until they covered most of the surface. Volcanoes, in their endless breathing, had given the planet its seas. These early oceans were not the calm blue expanses we know today. They were dark, mineral-rich, and steaming hot, infused with chemicals from volcanic gases. Carbon dioxide, sulfur, and nitrogen mingled with water, creating a strange toxic broth. Yet this chemical cocktail was not lifeless. It was in fact the foundation for life's first spark. Every eruption delivered new ingredients, from trace metals to vital gases, and the seas became a planetary laboratory, stirred by heat and rich in potential. The minerals brought forth from volcanic stone gave the oceans their flavour. Iron and magnesium leached into the water, along with silica and salts. Over time, these elements helped form the balance that makes seawater what it is. Even today, the composition of the oceans carries the signature of volcanic stone and steam. Every wave that laps against a shore, every drop that drifts skyward as mist, has its roots in that long-ago volcanic alchemy. There is something almost poetic about it. Volcanoes, known for fire and fury, were quietly midwives to water. Without intending it, they created the seas that would one day cradle whales, corals, and drifting continents of life. It is difficult to imagine such a contrast. Mountains spewing fire above, oceans swelling with water below, one born from the other. Fire and water, seemingly opposites, were in truth partners from the very beginning. The scale of this transformation cannot be overstated. More than 2/3 of Earth's surface is ocean, and nearly every drop of that water came originally from volcanic outgassing. Comets and icy asteroids may have contributed their share, sprinkling the planet with frozen deliveries, but the vast reservoirs were unlocked from within. Volcanoes were the great fountains of the world, feeding the skies until the weight of vapour broke into storms and the seas were born. As the oceans deepened, they began to shape the planet in return. rainfall weathered volcanic rock, dissolving minerals and carrying them into the basins. This slow erosion enriched the seas further, making them chemically complex. Waves pounded against newly formed coastlines, grinding stone into sand. The water that had fallen from volcanic breath was already busy remaking the world, smoothing its edges and softening its fiery face. Volcanoes continued to add their voice, erupting beneath the surface as well as above. Submarine volcanoes sent fountains of molten rock into the water, creating new land and releasing yet more minerals into the seas. Hydrothermal vents, like underwater chimneys, belched superheated water infused with metals and gases. In the dark depths, far from sunlight, these vents created small oases of chemistry and heat, strange environments that would later shelter some of the earliest life forms. Once again, volcanic fire and water worked together, providing not only oceans but the possibility of something more. The air changed too. With every eruption, volcanoes released carbon dioxide that dissolved into the oceans, forming carbonic acid. This interaction helped regulate the planet's temperature, preventing Earth from freezing despite a sun that was dimmer in its youth. In this way, oceans and volcanoes formed a climate partnership, balancing heat and keeping the surface stable enough for life to eventually appear. The seas were not just water. They were a planetary thermostat tuned by volcanic breath. Imagine looking upon the young Earth from afar. You would see a world wrapped in thick clouds, the surface hidden beneath swirling storms. Gradually, patches of ocean blue would appear through the haze, growing larger, reflecting the light of a young sun. Volcanoes, glowing red along fault lines and rising as islands, would punctuate the scene. It would have been a planet of contrasts, glowing fire beside endless water, thunderous eruptions beside the quiet lap of waves on newborn shores. These first oceans were alien to our eyes, yet they carried within them everything needed for life's story to begin. And the strange thing is, all of it happened without a plan. Volcanoes were not setting out to build seas or balance climates. They were simply venting, releasing what had been trapped within. By accident, they flooded the world with oceans. By accident, they made the surface habitable. By accident, they opened the door to everything that followed. It is humbling to think that every drop of water in a glass, every wave rolling toward the beach, and every storm cloud forming in the sky can trace its lineage back to volcanic fire. Oceans are the great unifiers of life, connecting every shore and carrying every tide, but their story began with steam drifting from stone. Fire gave us water, and water gave us the world. As the planet settled, the oceans deepened and spread, shaping continents and sculpting the face of Earth. From that point onward, water would be the constant companion of land, and volcanoes, though quieter, would continue to add their breath to the seas. Together they formed a world that was no longer only fire and stone, but a place where blue stretched endlessly, and where the possibility of life floated quietly on the waves. Long before forests swayed in the wind or waves crashed on familiar shores, Earth's skies were thick and alien. The atmosphere we breathe today is a delicate balance of nitrogen, oxygen, and trace gases, but in the beginning, there was nothing gentle about it. The first atmosphere of Earth was not something inherited from space, but something forged from the restless breath of volcanoes. With every eruption, the planet exhaled, and with every exhalation, the air began to take shape. In those early days, the crust was thin and fragile, riddled with cracks that vented heat from the still molten interior. Volcanoes dotted the landscape like glowing sores, releasing enormous plumes of gas that stained the skies. Carbon dioxide, nitrogen, sulfur dioxide, methane, hydrogen, and water vapor rose in choking clouds. To us, this would have been poison, but to a barren rock just emerging from chaos, it was the beginning of an atmosphere. The Earth was learning to breathe, and the breath was volcanic. Imagine standing on that young planet if such a thing were possible. The horizon would have been a blur of ash and smoke, the skies dim with haze. Lightning would have crackled through towering volcanic clouds, igniting chemical reactions in the swirling gases. To human eyes, it would have looked hostile, perhaps even hellish. And yet, within that chemical storm, the groundwork was being laid for something extraordinary. The gases pouring out of volcanoes had many fates. Water vapour condensed into rain, returning to the surface again and again, carving rivers and filling seas. Carbon dioxide thickened the air, trapping heat and preventing the planet from freezing beneath a weaker sun. Nitrogen, largely inert, began to accumulate as the most stable and dominant background gas, forming the bulk of the atmosphere we still breathe. Even methane and sulfur, though fleeting in large amounts, played their part in shaping the balance. This was no carefully arranged process. Volcanoes erupted because they had to, venting pressure and releasing what was trapped within. In doing so, they gave the planet a cloak of gases that transformed it from a naked rock into a world. Without this outgassing, Earth would have remained barren, exposed to the cold vacuum of space. With it, the surface was protected, warmed, and prepared for the long story of life that would follow. The first atmosphere was far different from the one we know. Oxygen, the gas most crucial to complex life, was almost entirely absent. Breathing this air would have been impossible for us. Instead, it was thick with carbon dioxide and nitrogen, creating a greenhouse effect that kept the planet warm. This warming was essential because the young sun shone dimmer than it does today. Without the volcanic greenhouse gases, Earth might have been locked in ice, an eternal snowball spinning in silence. Fire in the crust kept the world from freezing. What makes this atmosphere remarkable is not just that it kept the planet warm, but that it created a chemical playground. Ultraviolet light from the sun struck volcanic gases, sparking reactions that produced complex organic molecules. Lightning arcing through storm clouds added another layer of energy, assembling primitive chemical building blocks. The skies were not just thick with haze, they were alive with chemistry, preparing the foundations of biology. Nitrogen in particular deserves attention. Though quiet and unreactive, its steady accumulation created stability. Today, nitrogen makes up nearly 4/5 of the air we breathe, and that legacy began with volcanoes. Every burst of volcanic breath added more of this invisible gas to the skies, building a permanent background for all other atmospheric shifts. Without it, Earth's climate would have been wildly unstable, and life would have had little chance to endure. There is a beautiful irony here. The same forces we fear in volcanoes, the ash, the choking gases, the suffocating clouds, were the very forces that made breathing possible in the long run. Volcanoes poison the skies, and in poisoning them, they created the conditions for life to appear. Their destruction was also creation, their chaos also order. As the seas spread wider and deeper, they worked in tandem with the skies. Rain drew carbon dioxide from the atmosphere, dissolving it into oceans, where it reacted with volcanic minerals to form carbonate rocks. This process gradually balanced the greenhouse effect, preventing runaway warming. The oceans and the atmosphere entered into a quiet partnership, each shaped by volcanic input, each influencing the other. Together, they created the stable environment that life would one day inherit. Some scientists suggest that the very first sparks of life may have been nurtured by this volatile mix of gases. Volcanic hydrogen combined with carbon-based molecules in the presence of lightning could have formed amino acids, the raw ingredients of proteins. The skies may have been the earliest laboratory, a place where fire, water, and air conspired to make something new. In this sense, every breath we take today carries echoes of that first atmospheric experiment, born of steam and stone. Even now, modern volcanoes remind us of this heritage. Eruptions still send carbon dioxide, sulfur, and water vapor into the air. They may disrupt flights, cause acid rain, or briefly cool the climate, but they are also echoes of the same process that built the original atmosphere. Every eruption, is a reminder that the Earth is alive, that its deep interior is still connected to the skies. If the young Earth had been silent, sealed tight with no eruptions, it would have been a sterile planet. Without volcanic outgassing, there would have been no air, no rain, no seas, and no chance for life. Instead, the Earth exhaled in fire and smoke, and though the air was toxic at first, it became the scaffold upon which living systems could grow. What began as suffocation turned, in time, into breath. The first atmosphere was not perfect, but it was enough. It kept the surface warm, shielded it from space, and offered a stage for chemistry to dance. Over billions of years, photosynthetic organisms would take that volcanic inheritance and transform it, adding oxygen to the mix. But long before plants or animals, before even the simplest cells, there was only stone, fire, and sky. Volcanoes were the composers of that first atmosphere, writing the overture to a symphony that had not yet begun. It is easy to forget the air around us, so ordinary and invisible that we rarely notice it. Yet every breath carries a history written in eruptions and storms. When you inhale, most of what fills your lungs is nitrogen, a gas gifted by volcanoes. The carbon dioxide that plants depend on for photosynthesis has the same fiery origin. Even the water vapour that drifts in clouds once rose as steam from volcanic vents. To live on Earth is to live within the legacy of a volcanic sky. In the quiet of the present day, with stars shining in a clear night sky, it is hard to imagine the atmosphere as anything but serene. But its beginnings were far from calm. It was forged in fire, thickened by smoke, and balanced by storms. Volcanoes did not just shape the ground beneath our feet, they built the very air we depend on. By accident, by necessity, by the natural rhythm of a restless planet, they gave us an atmosphere. And in that invisible gift, they set the stage for everything that was to come. Volcanoes are often imagined as destroyers, their eruptions levelling landscapes and darkening skies. Yet hidden within that fiery violence is a quieter truth. Volcanoes are also extraordinary chemical laboratories. Each eruption is not just molten rock spilling outward, but a release of elements that have been locked away deep inside the Earth. Carbon dioxide, nitrogen, sulfur, and a suite of trace metals all billow upward in great plumes, mixing into the air, rain, and oceans. These ingredients, harsh and uninviting at first, became the foundation for life's earliest chemistry. To understand how life took hold, we have to appreciate the strange generosity of volcanoes. Consider carbon dioxide. Today it is spoken of mostly in the context of climate change, but billions of years ago it was a gift. When dissolved into the hot mineral-rich seas, carbon dioxide provided carbon, one of the essential building blocks of organic molecules. Without this steady volcanic supply, there would have been no chains of carbon atoms, no sugars, no amino acids, and certainly no cells. Every breath of carbon dioxide that poured from those ancient vents was a quiet invitation to chemistry. Nitrogen too arrived in volcanic breath. On its own, nitrogen is unreactive, a background gas that seems to do very little. But in the lightning-charged skies of the early Earth, nitrogen was transformed into more active compounds like ammonia and nitrates. These molecules are the fertilizers of life, feeding reactions that built proteins and nucleic acids. Without volcanoes steadily topping up the nitrogen supply, the first living systems might never have found the nourishment they needed to grow. Then there was sulfur. Its pungent, choking smell is the hallmark of volcanic activity even today, rising from fumaroles and hot springs. But sulfur did more than irritate the senses. It participated in some of the earliest metabolic pathways. Primitive microbes would later learn to harvest energy from sulfur compounds, turning volcanic gases into food. In this way, what might seem like poison became sustenance, and what seemed hostile became home. Volcanoes also gifted the world with trace metals, small in amount but mighty in impact. Iron, copper, zinc and nickel all emerged from volcanic eruptions and hydrothermal vents. These metals are catalysts, speeding up reactions that would otherwise crawl along too slowly to matter. Even now, within every living cell, metal atoms sit at the heart of enzymes, helping them fold molecules, split water, and capture energy. It is no exaggeration to say that life's machinery is built upon volcanic donations. Without those scattered elements, life's chemistry would have been sluggish, perhaps impossible. The setting for all of this was not sterile laboratories or clean beakers, but wild landscapes where fire met water. Along coastlines and in the deep ocean, volcanic gases bubbled into hot pools and vents, creating mixtures rich in minerals and energy. In these environments, the boundaries between air, rock, and water blurred. Molecules that would normally drift apart were instead concentrated, heated, and shocked into reacting. Some researchers imagined shallow volcanic pools drying and refilling over and over again, cycling simple molecules into complex chains. Others looked to deep-sea vents, where superheated water surged upward, carrying with it metals and gases that fueled intricate chemistry. The truth may be that both played a role, working together across different environments. What matters is that volcanoes created the conditions. They provided the raw materials, the energy, and the constant flux that made chemistry dynamic. In a way, volcanoes were like chefs, throwing ingredients into a vast planetary cauldron and stirring it with heat and motion. The recipe was not intentional, but it was effective. From carbon, nitrogen, sulfur, and metals, something remarkable began to emerge. Molecules that could copy themselves, adapt, and evolve. There is a certain elegance in this process. Life, which now seems so ordered and purposeful, began in chaos. The gases that stung the eyes and choked the lungs, the waters that boiled with minerals, the rocks that split and melted, all of it combined into a backdrop for creation. Volcanoes were not gentle hosts, but they were essential ones. Their eruptions may have looked like destruction, but on the molecular level, they were acts of construction. Even today, clues of this origin can be found in the way life functions. Many of the most ancient metabolic pathways rely on sulfur and iron, as though life still remembers its volcanic beginnings. Enzymes in modern cells use metal cofactors in ways that echo the chemistry of hydrothermal vents. The presence of carbon dioxide as a universal input into life's cycles speaks of those early volcanic skies. Life carries the fingerprints of volcanoes in every strand of DNA and every breath of oxygen. It is also worth remembering that volcanoes did not work alone. Lightning, ultraviolet light from the young sun, and the ceaseless mixing of oceans all played their part. But without the steady contribution of volcanic gases and minerals, these other forces would have had little to work with. Fire primed the stage, stocked the pantry, and filled the air with possibilities. For all their ferocity, volcanoes were patient in their chemistry. They erupted again and again for millions of years, each time adding more material to the surface and atmosphere. They did not stop after a single act of creation, but continued to enrich the seas long after the first molecules of life had appeared. Their role was not a brief spark, but a sustained contribution, a background hum of chemical generosity. Think of the irony. We often speak of volcanoes as destroyers of life, yet without them, life may never have begun. Their eruptions leveled forests and buried cities in later ages, but in the earliest times they gave the world its building blocks. Destruction and creation were never opposites here. They were two sides of the same coin, inseparable and necessary. The young earth was a place where fire gave rise to water, and water gave rise to life. Volcanoes stood at the centre of this transformation, their gases thickening the skies, their minerals enriching the seas, their heat powering reactions. They did not plan, they didn't design, but by accident they built a laboratory vast enough to create biology itself. When we look at a modern eruption, it is tempting to see only the ash and lava, the ruined homes and scorched fields. Yet hidden in those clouds are reminders of the chemistry that made us. The sulfur, carbon, and trace metals rising skyward are the same ones that once seeded life's beginnings. Every eruption is a whisper from the past, a reminder that our existence is tied to fire as much as to water. It is a humbling thought. Life in all its complexity may have started not in peace but in turmoil, not in gentle gardens but in volcanic cauldrons. Out of fire came chemistry, and out of chemistry came us. Every breath, every heartbeat, and every thought is connected to that fiery origin. Volcanoes, accidental chemists of the ancient earth, were not just builders of landscapes, they were builders of life itself. Beneath the waves, far from sunlight and the familiar rhythms of wind and tide, lies a world built entirely by fire. At first thought, the deep ocean might seem the least likely place to find the fingerprints of volcanoes. After all, water appears to smother fire, extinguishing flame as soon as it sparks. Yet the greatest volcanic activity on Earth does not happen in the open air, but hidden beneath the seas. Along vast mid-ocean ridges where tectonic plates drift apart, molten rock continuously wells up from below, creating new crust. And in that dark, pressurized world, something extraordinary happens. The birth of hydrothermal vents, the black smokers and shimmering springs that many scientists believe may have been the cradle of life itself. Imagine the scene. The seafloor stretches out in darkness, a place so deep that no sunlight has ever touched it. The pressure is immense, the water icy cold. Yet here, along jagged rifts in the crust, towering chimneys rise. From their mouths gush plumes of superheated water, rich in dissolved metals and minerals, pouring upward like underwater volcanoes in miniature. These are the black smokers, named for the dark clouds of iron sulfide particles they belch into the abyss. To a passing observer, they look like factories spewing smoke. But in truth, they are more like forges, endlessly shaping the chemistry of the deep sea. What powers these vents is volcanic heat. Beneath the seafloor, magma chambers simmer. Seawater seeps through cracks in the crust, plunging deep into the hot rock where it is heated to hundreds of degrees. Along the way, it leaches metals and sulfur from the stone, becoming a chemical broth under immense pressure. When it finally surges back up, it erupts from the vents as a scalding plume, rich in energy and elements. The contrast with the freezing water around it causes the minerals to precipitate, building towering chimneys of metal sulfides. Entire undersea landscapes are created by this process, landscapes alive with strange chemistry. For life, these vents are not just geological curiosities but potential origin stories. In the absence of sunlight, energy must come from somewhere else, and here it flows directly from the planet's interior. Microbes cluster around the vents, harnessing chemical gradients in the water to fuel metabolism. Instead of photosynthesis, they rely on chemosynthesis, using sulfur, methane, or hydrogen as energy sources. These tiny chemists turn volcanic gases into living matter, forming the base of ecosystems that thrive in perpetual night. Towering tube worms, ghostly crabs, and fields of clams all exist because microbes at the vents transform volcanic exhaust into food. It is in this strange, alien environment that scientists see clues to life's beginnings. The chemistry of hydrothermal vents provides everything necessary: heat, water, minerals, and a steady supply of energy. Some researchers suggest that within the microscopic pores of vent structures, organic molecules were concentrated and assembled into more complex forms. The iron-sulfur minerals that precipitate at the vents could have acted as primitive catalysts, speeding up reactions and helping to stabilize fragile molecules. Over time, simple compounds may have linked together into self-replicating chains, the ancestors of DNA and RNA. If this is true, then life did not begin in sunlight, but in volcanic darkness, cradled by stone and steam. The idea is more than poetic speculation. Many of life's most ancient metabolic pathways resemble the chemistry of vents. Modern cells still rely on iron-sulfur clusters to shuttle electrons, a direct echo of vent chemistry. Even the structure of cell membranes may trace back to the gradients of hot and cold water that swirl around hydrothermal systems. In this sense, our bodies carry a deep memory of volcanic seas, a heritage written into every cell. But whether or not life first sparked at hydrothermal vents, their role in sustaining life is undeniable. Across the oceans, vents form isolated oases of abundance. Where most of the seafloor is barren, vents are crowded with creatures. They are islands of life in a desert of darkness, thriving only because volcanoes provide heat and chemistry. Without volcanic energy, the deep oceans would be silent. With it, they pulse with strange vitality. These ecosystems also remind us of life's resilience. Creatures living at vents endure pressures that would crush submarines, temperatures that swing from freezing to boiling, and waters laced with toxins. Yet they flourish. They show that life can adapt to extremes, finding niches in places that once seemed impossible. And if life can thrive in volcanic darkness on Earth, perhaps it can thrive on other worlds too, wherever volcanoes and water meet. Indeed, the discovery of hydrothermal vents has reshaped our search for life beyond Earth. Moons like Europa and Enceladus, with their icy crusts and hidden oceans, may harbour vents powered by volcanic heat beneath the ice. If so, they could shelter alien microbes that mirror the chemosynthetic life of our own deep seas. In this way, the study of volcanic vents is not only about Earth's past, but about the possibilities of life across the cosmos. Even in the present day, vents play a quiet role in the planet's chemistry. They recycle elements between the crust and the oceans, releasing metals that drift into the water and influence marine ecosystems far beyond the vent fields. They shape the chemistry of seawater, maintaining balances that ripple outward through the entire biosphere. Their contribution is subtle but constant, another reminder that volcanoes never stop shaping the world. There is something deeply humbling about this vision. Volcanoes are not only mountain peaks spewing lava, but also unseen architects hidden under miles of ocean. Their reach extends into the most secret places of the planet, into the blackness where light never shines, and there, in the shadows, they may have lit the first spark of life. The next time you see a picture of a volcanic eruption, with its glowing rivers of lava and towering ash clouds, remember that somewhere in the deep ocean, volcanoes are at work in silence. They do not roar or blaze, but they build chimneys, exhale minerals, and sustain entire ecosystems. They are the quiet fire in the dark, shaping life just as surely as their louder cousins on land. From the earliest seas to the hidden ridges of the present day, underwater volcanoes and hydrothermal vents have been steady companions of life. They demonstrate that creation does not always need light, that warmth and chemistry can be enough. If life indeed began here, then every heartbeat and every breath is a distant echo of those black smokers, the volcanic forges that turned stone and steam into living matter. Fire, once again, proved itself not only a destroyer but a creator, and perhaps the greatest accidental gift of all. The world we walk on today, its towering mountains, sprawling continents and scattered islands, is the handiwork of slow and patient forces. Among the greatest of these architects are volcanoes. They are the builders that lifted land from the sea, stacked stone upon stone into mountain ranges, and stitched together the patchwork quilt of continents. When we admire a rocky coastline, a jagged peak, or even the soil beneath our feet, we are seeing the results of volcanic labour that has been ongoing for billions of years. Imagine the early Earth, its surface still mostly ocean, vast stretches of water wrapped around the globe, broken only by scattered volcanic islands that rose like lone sentinels from the waves. These islands were not placed there by chance. They were built by fire rising from the deep mantle, erupting through cracks in the crust, and slowly piling lava higher until it breached the surface. Each eruption added another layer, and with time, what began as a seafloor volcano became an island. In this way, the oceans that once seemed endless were gradually filled with stepping stones of land. Some islands appear in chains like pearls on a string. This is no coincidence. Beneath the crust, plumes of hot rock rise steadily from the mantle, creating hot spots. As tectonic plates drift slowly across these plumes, volcanoes erupt in sequence, leaving trails of islands that can stretch for thousands of kilometers. The Hawaiian Islands are perhaps the most famous example. The Big Island is still volcanically alive, while older islands to the northwest have long since gone quiet, eroded by waves into atolls and seamounts. The islands trace the movement of the Pacific Plate over millions of years, a visible record of Earth's restless engine. But islands are only part of the story. Volcanoes have also been instrumental in building the continents themselves. Early in Earth's history, most crust was oceanic, thin, dense, and easily recycled back into the mantle. It was through repeated volcanic eruptions that lighter, silica-rich rock accumulated, thickening the crust and forming the foundations of continental landmasses. Layer upon layer of volcanic rock eventually welded together into vast blocks of land that resisted subduction. These became the nuclei of continents, the stable cores upon which modern landscapes were built. Without this slow accumulation of volcanic material, Earth might still be a water world dotted only with scattered volcanic islands. Volcanoes also shaped the dramatic relief of mountain ranges. Where tectonic plates collided, one plate would sink beneath another, dragging water and sediments down into the mantle. This subduction caused the mantle above to melt, fueling volcanic arcs along the edges of continents. The Andes in South America, for example, were born from this fiery process, their peaks crowned with volcanoes that still fume and rumble today. Similarly, the volcanic arc that stretches from Alaska down through the Pacific coast has been raising mountains for millions of years, a living reminder of how fire and collision build landscapes on a continental scale. Even the Himalayas, though often thought of as purely the result of tectonic collision, owe part of their structure to ancient volcanic activity. When India slammed into Asia, volcanic eruptions helped contribute to the formation of high plateaus and provided material that thickened the crust. The mountains we see today are not just the result of plates colliding, but also of magma intrusions that harden deep within, forming the granite cores of peaks. Beyond mountains, volcanoes have been responsible for creating vast plateaus. The Deccan Traps in India and the Columbia River Basalt Group in North America are monumental examples of flood basalts, enormous eruptions that spread lava across thousands of square kilometers. These eruptions reshaped entire regions, leaving behind thick layers of volcanic rock that now form landscapes of rolling hills, cliffs, and fertile valleys. In building these plateaus, volcanoes quite literally redefined the map of the continents. The slow architectural work of volcanoes also extended to the deep ocean. Mid-ocean ridges, where plates pull apart, are the single largest volcanic feature on Earth, stretching more than 60,000 kilometers around the globe. Though hidden beneath the waves, these ridges continuously produce new crust, pushing old crust aside and slowly rearranging continents and ocean basins. It is here that much of Earth's surface is manufactured, a vast assembly line of volcanic rock that never stops. The continents themselves ride along this conveyor belt, drifting, colliding, and reshaping as volcanic forces beneath them churn. What is remarkable is the patience of this construction. Volcanoes work in cycles measured not in years or centuries, but in millions of years. Islands rise, erode, and vanish. Mountains are uplifted, then worn down by wind and water. Continents break apart and drift back together in a cycle that has repeated for billions of years. Through it all, volcanoes are the masons, lifting new stone from below and adding it to the ever-changing design. Their work is not just structural but ecological. The new lands created by volcanic eruptions become habitats, testing grounds for life. Islands emerging from the sea are barren at first, but over time seeds arrive by wind or wave. birds settle, and ecosystems form. The Galapagos Islands are a living testament to this process. They're unique species shaped by the volcanic landscapes they inhabit. Without volcanoes, there would be fewer laboratories of evolution, fewer opportunities for life to experiment and diversify. It is easy to take continents for granted, as though they were always here, fixed and eternal. Yet every mountain peak, every island chain, and every vast plain is a reminder of volcanic persistence. The Earth we know is not a given. It was built piece by forces that rose from the deep. The continents are archives of fire, each rock a page in the story of eruptions long past. Consider for a moment the irony. Volcanoes are often described as destructive, yet their greatest legacy is creation. They bury forests, but they also build new ground for forests to grow again. They collapse coastlines, but they also raise new islands from the sea. Over time, their destructive outbursts add up to something enduring. Mountains that shape weather, continents that cradle civilizations, and soils that nourish life. Destruction and creation are not opposites in their story. They are inseparable partners. When you look at a globe, every outline of land you see, every continent, every island, every coastline, owes something to volcanoes. They are the quiet architects of geography, their blueprints drawn not in ink but in molten rock. Without their ceaseless building, the Earth would be unrecognizable, a world of water with little solid ground to anchor life. The continents beneath our feet are monuments to fire. They tell us that even in destruction, there can be creation, and that the planet we call home is not static but alive. Volcanoes raised the land, stitched the islands, and carved the mountains, and though their pace is slow, their work is relentless. The map of the world is their masterpiece, a canvas painted not in a single stroke, but through billions of years of fiery persistence. Volcanoes are often remembered for their power to devastate. When a mountain erupts, forests vanish beneath ash, rivers of lava carve through fields, and landscapes seem erased in a matter of hours. Yet hidden within that destruction lies one of the greatest gifts volcanoes have ever given the world: soil. Out of cooled lava and scattered ash comes some of the most fertile ground on Earth, a foundation for forests, grasslands, and eventually human agriculture. Where volcanoes have burned, life has often returned stronger than before. The magic begins with the rock itself. Freshly erupted lava looks lifeless, black, and unyielding, as though nothing could ever grow on it. But over time, water, wind, and temperature work their quiet transformations. The rock weathers and crumbles into smaller fragments, releasing the minerals locked inside. Elements like potassium, phosphorus, calcium, and magnesium are set free, blending with organic matter to form soil. These are the nutrients plants crave, and when they are abundant, landscapes flourish with a richness found almost nowhere else. Volcanic soils, often called andesols, are famous for their fertility. Unlike the thin, nutrient-poor soils of many ancient landscapes, andesols are packed with minerals and have a remarkable ability to hold both water and nutrients. They form quickly after eruptions, creating a stage where life can return in abundance. What begins as a barren lava plain can, within centuries, turn into lush forest or rolling farmland. For plants, volcanic soils are something close to paradise. Forests often reclaim volcanic slopes first. Seeds carried by wind or birds settle in the ash, and within a few generations trees take root. In places like Indonesia, the Philippines, and Central America, volcanoes are surrounded by dense jungles, their richness owed to the fertile ground below. The soils act as reservoirs, holding moisture even during dry periods, allowing forests to thrive in climates that might otherwise be harsher. These forests in turn support extraordinary biodiversity, from insects and birds to large mammals. Without volcanoes, many of these ecosystems would be far less vibrant. Grasslands too have flourished on volcanic soils. The East African Rift, dotted with volcanoes, is home to some of the richest savannas in the world. Herds of wildebeest, zebras, and gazelles graze on grasses nourished by volcanic minerals, while predators follow close behind. The abundance of wildlife in these regions is directly tied to the generosity of the soil beneath them. Without the slow grinding of volcanic rock into nutrients, the plains of Africa might never have supported such vast, thriving communities of life. Humans, of course, discovered this gift long ago. Throughout history, people have been drawn to volcanic regions not only for their dramatic landscapes, but for their fertile land. Ancient civilizations like those around Mount Vesuvius, Mount Etna, and Mount Fuji thrived because of the crops they could grow in volcanic soils. The same is true for the fertile valleys of Java and the highlands of Central America, where volcanic ash nourishes rice, maize, coffee, and countless other crops. People settled near volcanoes despite the risks because the rewards were so great. The paradox is striking. Volcanoes can wipe out entire communities in a single eruption, yet in the long run, they ensure those same lands remain capable of sustaining people. Farmers in Naples plant vineyards on the slopes of Vesuvius, producing grapes with flavours enriched by volcanic minerals. Coffee from volcanic soils in Central America is prized for its depth and richness. In Iceland, volcanic ash has been used to improve pastures, turning rough land into green fields. The same mountain that may once have threatened life becomes, in time, the source of survival. This cycle of destruction and renewal is part of what makes volcanic soils so special. Unlike older soils that have been leached of nutrients by millions of years of rainfall, volcanic soils are constantly refreshed. Each eruption lays down a new layer of ash, rich in minerals, ready to be broken down into the next generation of fertile ground. It is as though volcanoes are forever resetting the clock, ensuring that their slopes remain productive long after other lands have grown weary. The connection between volcanoes and flourishing life extends even further. Nutrients carried by volcanic ash do not stay on land alone. Winds can lift ash high into the atmosphere, scattering it across great distances. When it settles into oceans, it delivers a feast of iron and other elements that stimulate plankton growth. These tiny organisms are the foundation of marine food webs, supporting fish, whales, and seabirds. In this way, eruptions fertilize not just fields and forests, but entire stretches of ocean. Life on land and sea both draw nourishment from volcanic breath. There is also something symbolic in this relationship. Out of the fiery heart of the planet comes the very ground that sustains life. Where we see devastation, nature sees opportunity. Where we see ruin, the earth is quietly preparing abundance. Life and death are not opposites here, but parts of the same cycle, joined by the patient work of weathering, rain, and time. The ash that buries a forest today will one day feed another forest, greener and more diverse than before. Of course, volcanic soils are not without their challenges. They can be prone to erosion, especially when heavy rains wash across loose ash. Farmers have had to learn how to manage these soils carefully, building terraces or planting cover crops to hold the land together. But when tended wisely, the yields are extraordinary. Time and again, people have chosen to live in the shadows of volcanoes, knowing the danger but also recognizing the promise of fertile ground. The next time you bite into a piece of fruit, sip a cup of coffee, or enjoy a glass of wine, it is worth pausing to consider the hidden role of volcanoes. Much of what sustains us can be traced back to their mineral gifts, the flavors of certain crops, the richness of pastures, the very abundance of food in some regions, are all the legacy of fire turned to soil. Volcanoes are often cast as destroyers, but their soils tell another story. They are givers of life, patient recyclers of stone into nourishment, silent allies of forests and farmers alike. They remind us that creation is often disguised as ruin, and that the most barren landscapes can, with time, become the most fruitful. In the end, the lush fields, jungles, and savannas that cover volcanic slopes are monuments not just to life, but to resilience. they show us that out of devastation can come renewal, and that the earth has always known how to turn fire into food. Volcanoes grind rock into soil, soil feeds plants, and plants sustain animals and humans alike. It is a cycle as old as the planet itself, and it continues quietly beneath our feet. The fire of the earth, once unleashed in destruction, is also the reason life flourishes in abundance. Life has never had the luxury of existing on a quiet, unchanging world. From the very beginning, the surface of Earth has been restless, shifting and breaking under the pressure of forces deep within. Volcanoes, in particular, have been powerful sculptors of life's trajectory. Each eruption, each outpouring of lava or plume of ash, has reshaped ecosystems in ways both subtle and dramatic. At times, volcanoes have cleared the stage entirely, wiping out vast numbers of species. At other times, they have opened up new opportunities, forcing life to adapt, diversify, and explore possibilities that would otherwise have remained hidden. Evolution owes many of its twists and turns to fire rising from the earth. Consider the immediate aftermath of a major eruption. An entire landscape might be buried under meters of ash or lava, its forests and rivers erased. To us, this looks like ruin. To evolution, it is a reset button. When life eventually returns, it does not simply restore what was lost, but experiments with new combinations. Plants and animals that can endure the harsh conditions of volcanic soils establish themselves first, and their presence sets the stage for others. Over thousands of years, entirely new ecosystems can arise from the blank canvas left behind by fire. Some of the most striking examples of this are found on volcanic islands. The Galapagos, Hawaii, and Iceland were all built by eruptions, their lands barren at first. When plants and animals arrived, often by chance, they found isolated laboratories of evolution. With no competitors or predators, species adapted in strange and unique ways. Charles Darwin's famous finches, each with differently shaped beaks, are perhaps the most well-known case. Their evolutionary experiments were possible only because volcanoes created the islands in the first place. In this sense, volcanoes are not just destroyers, but also creators of opportunity, offering life a chance to innovate in fresh environments. But volcanic influence goes far beyond individual islands. Some of the greatest turning points in Earth's history were tied directly to eruptions on a massive scale. The Siberian Traps, for example, erupted about 250 million years ago, releasing enormous volumes of lava and gases over a span of hundreds of thousands of years. The result was the most devastating extinction in Earth's history, wiping out around 90% of marine species and 70% of land species. Ecosystems collapsed, and life seemed to teeter on the brink of annihilation. Yet out of this catastrophe came the opening for new groups of organisms to dominate, paving the way for the rise of the dinosaurs. Later, another flood of volcanic activity in India, known as the Deccan Traps, coincided with the end of the dinosaurs 66 million years ago. Though an asteroid impact is usually blamed for their demise, the Deccan eruptions would have compounded the devastation, filling the skies with ash and carbon dioxide, altering climates for tens of thousands of years. It was a double blow that cleared the way for mammals to rise, eventually leading to the lineage that produced humans. Without those volcanic outpourings, the evolutionary path might have looked very different indeed. Even on smaller scales, volcanoes have constantly nudged evolution. Local eruptions that destroyed habitats forced species to migrate, adapt, or vanish. Those that survived carried traits that made them more resilient to change, and those traits were passed on. Over time, this continual pressure honed species into forms better suited to a dynamic world. Life did not evolve in spite of volcanoes, but in conversation with them. Volcanoes have also shaped evolution by influencing climate. When eruptions spew sulfur dioxide into the atmosphere, it can reflect sunlight and cool the planet. When carbon dioxide dominates, the opposite happens, warming the climate. These swings in temperature, sometimes lasting centuries, have reshaped where species could live and how they adapted. Ice ages and warm periods alike have been nudged, in part by the restless breath of volcanoes. Evolution responded accordingly, rewarding flexibility and innovation. In more recent times, volcanic disruptions have altered human history. The eruption of Mount Toba about 74,000 years ago may have caused a volcanic winter, drastically reducing human populations. Some scientists believe this bottleneck forced our species into a period of rapid innovation and migration, shaping the course of human evolution. While the details are debated, the idea underscores the same truth. Volcanoes are not distant background scenery, but central players in life's unfolding story. Yet it would be misleading to think of volcanoes only as catastrophic. They have also been gentle guides. By continually producing new land and enriching soils, they have encouraged the spread and diversification of plants and animals. By raising mountains, they have created barriers that separate populations, allowing species to diverge along different evolutionary paths. By scattering islands across oceans, they have provided stepping stones for colonization. Life's diversity is, in many ways, a patchwork stitched together by volcanic geography. Think of the countless species that owe their existence to volcanic landscapes. The unique birds of Hawaii, the reptiles of the Galapagos, the hardy mosses and lichens of Iceland, all are products of life adapting to environments that did not exist until fire raised them from the sea. Each eruption that seemed to erase life was also, in the long run, an invitation for life to try again, differently this time. This duality is what makes volcanoes so fascinating. They are both destroyers and creators, endings and beginnings. They have triggered extinctions that seemed absolute, and yet those extinctions cleared space for entirely new worlds of life. They have disrupted climates and collapsed ecosystems, but they have also fertilized soils, raised islands, and driven the diversity that makes our planet so astonishingly rich. Evolution is not a smooth, gentle path. It is a rugged journey shaped by upheaval, and volcanoes have been among its most persistent companions. When we look at the living world today, we see the results of countless volcanic influences. Every forest, every savanna, every coral reef has ancestors that were tested, challenged, or reshaped by fire. The resilience of life, its ability to adapt and flourish, is inseparable from the upheavals that volcanoes have unleashed. It is almost as though volcanoes, in their blind restlessness, have been unwitting teachers, pushing life to be stronger, more creative, and endlessly adaptable. And so, the course of evolution cannot be told without them. Volcanoes have sculpted the terrain of Earth, but they have also sculpted the story of life itself. They have erased, but they have also inspired. From mass extinctions to the blossoming of new species, from barren islands to thriving ecosystems, the fingerprints of volcanoes are everywhere. In their fire and ash, they carried the seeds of possibility, and in their destruction, they carved space for renewal. The great story of evolution is not just one of genes and adaptation, but of fire reshaping the stage upon which life performs. Every so often, the Earth reminds us that even the grandest eruptions we witness today are but sparks compared to what it is capable of. Most volcanoes, though destructive, are local events. They bury towns, alter landscapes, or briefly disturb climates. But there exists a rare class of eruptions so immense, so world-altering, that the term supervolcano had to be coined to describe them. These are not the familiar cone-shaped peaks or island builders. They are vast calderas sleeping beneath the surface, storing unimaginable amounts of magma until the moment of release. When they awaken, they do not merely change landscapes. They press reset buttons on entire chapters of life and climate. One of the most famous examples lies beneath the forests and geysers of Yellowstone in North America. Today, visitors see hot springs shimmering with colours, geysers shooting skyward, and pools of boiling mud. These are gentle reminders of a restless giant below. Around 2 million years ago, Yellowstone unleashed one of the largest eruptions in Earth's history, ejecting thousands of cubic kilometres of ash and lava. The explosion left behind a colossal caldera, now hidden under forests and lakes. The impact was not just local. Ash spread across continents, skies darkened, and climates shifted. Though life survived, the world was shaken into a new balance, ecosystems forced to adapt under different conditions. Yet Yellowstone is only one chapter in a long book of colossal eruptions. Another, even more dramatic, occurred around 74,000 years ago in what is now Indonesia. The eruption of Mount Toba was so vast that it is considered one of the most severe volcanic events humans have ever endured. The caldera it left behind is now Lake Toba, stretching 100 kilometers across. The eruption spewed so much ash into the atmosphere that sunlight was dimmed across the globe, leading to what scientists call a volcanic winter. Temperatures plummeted, crops withered, and ecosystems faltered. For early humans, the event may have been catastrophic. Some studies suggest that our species was reduced to small populations, forced to adapt under intense stress. Whether or not this bottleneck was as severe as once thought, it is clear that Toba reshaped the trajectory of both climate and humanity. Supervolcanoes remind us of scale. When Krakatoa erupted in 1883, its explosion was heard thousands of kilometers away, and its ash circled the globe, altering sunsets for years. Yet even Krakatoa was a fraction of the size of a super-eruption. The ash and gases released by Toba, Yellowstone and others of their kind dwarfed such events, covering continents in layers of ash meters thick and altering atmospheric chemistry for decades. These eruptions were less like fireworks and more like the earth heaving a great sigh, releasing pressure built up over immense spans of time. The consequences of such eruptions ripple across biology as well as climate. Ash clouds reduce sunlight, disrupting photosynthesis on land and in the oceans. Crops fail, forests die back, and food chains collapse. But in the aftermath, survivors find a world reshaped, new niches opened, and competition thinned. Evolution seizes these moments, branching into directions that would have been unlikely in calmer times. The extinctions that follow supervolcanoes are tragic, but they are also opportunities. The course of life bends, sometimes dramatically, when the world resets. Consider how Toba may have influenced human adaptability. If populations were indeed pushed to the brink, the survivors would have been forced to innovate, to cooperate, and to migrate. Some scientists suggest that this stress accelerated the spread of humans out of Africa, shaping the course of civilization itself. It is a haunting thought, that a single eruption could have changed the entire history of our species, not through fire alone, but through the quiet chill that followed in its ash-darkened skies. Yellowstone's eruptions, though far older, may have had similar impacts on life in their time. Vast stretches of North America were blanketed in ash, ecosystems erased in an instant. The shockwaves extended across continents, disrupting climates in ways that forced plants and animals to adjust or vanish. Fossil records suggest waves of extinction followed, while others show bursts of diversification in the survivors. Each super-eruption, destructive as it was, acted as an evolutionary turning point. And Yellowstone is not unique. The Taupo volcanic zone in New Zealand has produced colossal eruptions, one of which about 26,000 years ago ranks among the largest in recent memory. The Campanian ignimbrite eruption in Italy around 40,000 years ago scattered ash across Europe and may have influenced the survival of early human populations, including the Neanderthals. These events were not isolated disasters, but global perturbations, moments when the entire planet seemed to shudder under volcanic force. What makes supervolcanoes so mysterious is their silence. Unlike a towering cone that smokes and rumbles before erupting, many supervolcanoes slumber invisibly beneath the crust. Their only hints are geothermal features, hot springs, geysers, and uplifted ground. Their timelines are measured not in centuries but in hundreds of thousands of years, making prediction difficult. We live in a world still dotted with these hidden giants, from Yellowstone to Lake Toba, from the Andes to the Mediterranean. Their presence is a reminder that the story of Earth is far from finished. Yet for all their menace, supervolcanoes also embody balance. They are part of the planet's way of releasing heat and reshaping its surface. Without such eruptions, the Earth would look very different. Continents would not drift as they do, mountains would not rise in the same patterns, and climates might never have shifted in the ways that drove evolution forward. Even their darkest moments are woven into the larger fabric of life. It is easy to shiver at the thought of a sky dimmed for years, of fields turned to ash, of species vanishing in a geological blink. But it is also worth marvelling at the resilience of life in the face of such upheaval. Every reset has been met with regrowth, every devastation followed by renewal. Forests reclaim volcanic slopes, animals repopulate valleys, and humans themselves have thrived on the very lands once buried by fire. Life bends, adapts, and persists, even under the shadow of the greatest eruptions. Supervolcanoes are reminders of humility. They show us that the Earth is not ours to command, but a living system that has shaped us as much as we have shaped it. They are vast, slow, and indifferent, yet in their indifference, they have been accidental guides of life's story. The resets they triggered cleared the way for new worlds of possibility, even as they erased what came before. When we gaze at a calm lake filling the caldera of a long-dead eruption, or walk through forests growing on volcanic soils, it is easy to forget the cataclysms that created them. But hidden beneath that calm beauty is a memory of fire so immense it altered the destiny of species and climates alike. Supervolcanoes, in their rare and terrible awakenings, have pressed reset on Earth more than once, and though they are among the most destructive forces our planet has ever unleashed, they have also been the great reshapers, ensuring that the story of life has never stood still. There is a peculiar beauty in the idea of fire and ice sharing the same stage. One is the symbol of destruction and heat, the other of stillness and cold. Yet on our restless planet, the two are not opposites at all, but partners locked in an ongoing dance. Beneath the world's glaciers and ice sheets, volcanoes lie in wait, their molten heat pressing upward against the frozen weight above. When they meet, landscapes are transformed in ways that are both violent and strangely elegant. Nowhere captures this paradox more vividly than Iceland and Antarctica, where volcanoes burn quietly beneath ice, shaping worlds that seem at first glance to be entirely frozen. Iceland is often described as the land of fire and ice, and the name is no exaggeration. Sitting astride the mid-Atlantic ridge, it is one of the most volcanically active places on Earth, its surface riddled with fissures, lava fields, and geothermal vents. Yet much of its interior is also draped in glaciers, vast white caps that conceal valleys and peaks beneath their frozen weight. Here, eruptions often occur beneath thick ice, creating surreal events known as subglacial eruptions. Instead of towering fountains of lava, the first sign may be sudden floods of meltwater, known locally as Jökullaups, that roar out from beneath the ice with little warning. These floods can reshape valleys overnight, carving new channels and sweeping away everything in their path. The process is a tug-of-war between fire and ice. When magma pushes upward into a glacier, the ice melts rapidly, forming pockets of water trapped beneath the frozen surface. Pressure builds until the water bursts forth, releasing torrents that can rival the flow of mighty rivers. Once the eruption breaks free, the lava itself is chilled instantly by the ice, shattering into glassy fragments that pile into unusual formations. Instead of broad cones, subglacial eruptions can build flat-topped mountains called tuyas, created when lava is confined beneath ice before finally breaking free into the open air. Iceland's landscapes are filled with these volcanic oddities, silent reminders of fire's secret encounters with ice. The contrast is mesmerizing. On one hand, the raw power of magma rising from deep inside the earth, glowing at temperatures of more than 1,000 degrees. On the other, glaciers that have accumulated for centuries, solid and unyielding, pressing downward with crushing weight. And yet when they meet, the result is not stalemate but transformation. Ice melts, water floods, rock fractures, and entire valleys are reborn. Iceland itself would not look as it does without this marriage of extremes. Antarctica tells a quieter but equally fascinating version of this story. Beneath its miles-thick ice sheet, more than 100 volcanoes are known to exist, their presence detected through radar, seismic surveys and geothermal clues. Some, like Mount Erebus on Ross Island, are visible above the ice, puffing gently with persistent activity. Others remain hidden, buried deep beneath glaciers. Though most are dormant, their heat still influences the ice sheet above, melting it from below and shaping how glaciers flow toward the sea. Even without erupting, these volcanoes are sculptors, subtly undermining the frozen facade. When eruptions do occur beneath Antarctic ice, the effects can be dramatic. Molten rock melts vast cavities at the base of glaciers, forming hidden lakes that may drain suddenly, lubricating ice flows and accelerating their slide into the ocean. Such events can influence sea levels on a global scale, a reminder that even in the coldest places on Earth, fire still has the power to reshape the fate of coastlines thousands of kilometers away. Antarctica's frozen deserts are not as static as they appear. They are restless landscapes, stirred from below by volcanic heat. This unlikely partnership of fire and ice also creates habitats that are surprisingly rich in life. In Iceland, geothermal hot springs at the edges of glaciers form oases, where mosses, microbes and hardy plants thrive in otherwise barren surroundings. In Antarctica, subglacial lakes warmed by volcanic heat may harbour unique microbial communities, sealed away from the surface for millions of years. These are not just scientific curiosities, but glimpses into how life might survive in extreme environments elsewhere. From the icy moons of Jupiter and Saturn to the frozen crust of Mars. If life can cling to warmth beneath ice on Earth, why not elsewhere in the cosmos? There is also a human dimension to this dance. Icelanders have long lived with the knowledge that their glaciers conceal fiery hazards. Legends and folklore describe the floods and eruptions, turning natural disasters into tales of giants and gods. At the same time, people have learned to harness the geothermal energy born from this relationship, heating homes and powering cities with the warmth of underground fire. It is a perfect illustration of how humanity adapts to extremes, turning a marriage of opposites into a source of survival. The landscapes created by volcanoes beneath ice are unlike any other. Flat-topped tuyas, vast floodplains scoured by Jökullaups, ice caves glowing with geothermal heat. They remind us that Earth is capable of producing beauty from contradiction. These places feel almost alien, as though we are glimpsing another planet entirely, and in a sense, we are. The interaction of fire and ice here on Earth may be one of the closest analogues we have to the environments of icy moons elsewhere. What makes this partnership especially fascinating is its unpredictability. Volcanoes beneath glaciers cannot be monitored as easily as those above ground. Their eruptions often remain hidden until sudden floods burst forth, or satellites detect unusual changes in ice flow. They are secret volcanoes, working in silence, their artistry revealed only after the fact. This hidden quality adds to their mystery, reminding us how much of Earth's story remains unseen beneath the surface. It is tempting to think of ice and fire as enemies, forever trying to erase each other. But in truth, they collaborate in shaping the world. Ice sculpts valleys and carves glaciers, while fire melts, fractures, and reshapes them in turn. The result is a landscape neither element could create alone. Iceland's mountains, Antarctica's hidden lakes, and even the fertility of glacial floodplains all exist because of this strange alliance. In the end, volcanoes beneath glaciers are reminders that the Earth thrives on paradox. Fire can live beneath ice, heat can shape cold, destruction can create new forms of beauty. These encounters between extremes have sculpted some of the planet's most remarkable landscapes and offered life unlikely places to flourish. The world is richer, stranger, and more resilient because fire and ice, instead of cancelling each other out, chose to build together. Far beneath the waves, in places no sunlight has ever reached, lies the greatest volcanic system on Earth. It is not a single peak or even a chain of mountains, but a vast network stretching like the seams of a baseball around the globe. These are the mid-ocean ridges, immense underwater mountain ranges where the planet is constantly renewing itself. Here, fire meets water in silence, a new crust is born every day. Though hidden from ordinary view, these ridges are the true factories of the Earth's surface, producing more volcanic rock than all land volcanoes combined. The scale of this system is staggering. The mid-ocean ridges extend for more than 60,000 kilometers, making them the longest mountain range on the planet. Yet most of it lies 2 to 3 kilometers below the surface of the ocean, shrouded in perpetual darkness. Where tectonic plates pull apart, molten rock from the mantle wells upward, filling the gap with fresh lava. As it cools, it hardens into new crust, pushing the plates apart ever so slowly. This process, called seafloor spreading, has been running for hundreds of millions of years, continuously recycling the ocean basins and shaping the continents that ride on top. It is strange to think that the ground beneath our feet owes its existence to these hidden ridges. Almost every patch of ocean floor was once molten rock that erupted at a ridge, cooled, and then drifted outward. Over time, this conveyor belt of crust carries seafloor thousands of kilometers from where it was born before it is eventually recycled into the mantle that subduction zones. The ocean floor beneath the Atlantic, for example, is slowly widening as the mid-Atlantic ridge produces new crust and pushes the continents farther apart. Europe and the Americas drift like passengers on a raft, unaware of the fiery machinery beneath them. The activity at these ridges is not explosive like the eruptions we see on land. Instead, it is more like a constant leaking of lava. Basaltic magma oozes out through cracks, spreading into pillow-shaped formations that pile up along the ridge. These pillow lavas are strange bulbous structures, formed when molten rock meets cold seawater and solidifies instantly on the outside while still flowing inside. Layer upon layer of pillow lava builds the ocean crust, a process both patient and relentless. It is not dramatic in the moment, but over millions of years it reshapes the map of the world. Alongside the lava flows, hydrothermal vents add another layer of intrigue. As seawater seeps into cracks and meets hot magma below, it is superheated and enriched with metals before bursting back out as plumes. These vents, often clustered along the ridges, create mineral deposits and sustain vibrant ecosystems that exist entirely without sunlight. Black smokers, white smokers, and shimmering chimneys mark the places where Earth's hidden chemistry meets the ocean. In these dark oases, microbes thrive by using chemical energy, forming the base of food chains that include crabs, shrimp, worms, and fish. The ridges are not only factories of crust, but also factories of life, showing us that heat and chemistry can sustain biology even in the absence of light. The mid-ocean ridges also play a crucial role in Earth's climate system. By releasing carbon dioxide and other gases, they act as regulators of the atmosphere. Some of this carbon dioxide is absorbed by seawater, influencing ocean chemistry, while some rises into the air, balancing the global carbon cycle over geological time. The rate of seafloor spreading even influences sea level. When ridges are particularly active and buoyant, they displace water, raising oceans higher. When activity slows, sea levels fall. In subtle ways, these underwater ridges help dictate the rhythms of climate and coastlines. Despite their hidden nature, the ridges have left their mark in ways we can trace. Magnetic minerals in the basalt record the orientation of Earth's magnetic field at the time they cooled. As new crust forms and spreads outward, it preserves stripes of magnetic polarity, a barcode of Earth's shifting field. These patterns were the smoking gun that confirmed the theory of plate tectonics in the 20th century. The ridges revealed not only their own activity, but the restless motion of the entire planet. It is astonishing that something so vast and vital remained hidden until modern times. For most of human history, the deep ocean was a mystery, its floor assumed to be flat and featureless. Only in the mid-20th century did sonar mapping reveal the ridges rising from the seafloor like submerged mountains. What was once thought to be emptiness turned out to be a planet-spanning engine of creation. It is a reminder of how much of Earth still lies unseen, its greatest features concealed beneath kilometres of water. To imagine walking along one of these ridges is to imagine a world both alien and familiar. Dark basalt stretches in every direction, interrupted by glowing vents and strange creatures clustered around them. In the distance, fresh lava oozes slowly from fissures, steaming as it cools. The ground beneath your feet is young, measured in mere thousands of years, compared to the billions of years recorded in continental rocks. The ridges are places of eternal youth, where Earth continually remakes itself. The importance of these ridges extends beyond geology and biology. They also remind us of the interconnectedness of the planet. The continents we live on drift because the seafloor spreads. The climate we experience is influenced by gases that bubble up from underwater fissures. Even the minerals we use, copper, zinc, and rare metals, are concentrated in deposits around hydrothermal vents. Our lives on the surface are bound to the hidden work of fire in the deep ocean. There is a quiet poetry in this process. While we often think of volcanoes as towering cones that dominate landscapes, the greatest volcanic activity of all is carried out in silence and darkness. No eruptions light the sky, no ash clouds blot out the sun. Instead, magma rises steadily from the mantle, cooled by seawater, and forms the crust that carries us all. It is creation without spectacle, a reminder that not all powerful forces announce themselves loudly. Some work quietly, patiently, over eons, reshaping the world one pillow of lava at a time. So much of the Earth's beauty, from mountain ranges to fertile plains, ultimately depends on the ridges hidden beneath the oceans. They are the planet's true heartbeat, the places where its inner fire breaks through and begins the journey that will eventually raise continents and feed civilizations. Though invisible to most of us, they are the foundation of the world we know. When you stand on land, it is worth remembering that the stone beneath your feet was likely born in darkness, at a fiery ridge on the floor of the sea, part of a process that has never once paused since the Earth began to cool. Encircling the vast Pacific Ocean is a belt of extraordinary energy, a chain of volcanoes and earthquake zones that together form what is known as the Ring of Fire. It is not a ring in the sense of a neat circle, but rather a sweeping horseshoe that stretches for more than 40,000 kilometers, touching the coasts of the Americas, crossing northward through Alaska, sweeping down past Japan and the Philippines, and continuing south through Indonesia and New Zealand. This immense arc is the most volcanically active region on Earth, home to 3/4 of the world's active volcanoes and the majority of its great earthquakes. It is a place where the planet never truly rests. The restless energy of the Ring of Fire is the result of tectonic plates colliding, sliding, and diving beneath one another. The Pacific Plate, one of the largest on the planet, is surrounded by smaller plates that are forever shifting and grinding against it. Where one plate is forced under another in subduction zones, magma rises from the mantle, fueling chains of volcanoes. The Andes, the Cascades, the Aleutian Islands, the mountains of Japan, and countless others owe their existence to this fiery boundary. It is a reminder that the ground we stand on is not fixed, but floats on a restless sea of stone. Travelling around the Ring of Fire is like following a necklace of volcanoes, each bead with its own history, culture, and personality. In South America, the Andes rise in a majestic line, their peaks capped with snow but hiding fiery hearts. Volcanoes such as Cotopaxi in Ecuador or Villarrica in Chile stand as guardians over valleys where people have lived for centuries, their soils fertile but their temperaments unpredictable. Entire civilizations, from the Inca to modern farmers, have thrived in these volcanic landscapes, accepting the risks in exchange for the richness of the land. Moving northward, the Ring of Fire sweeps along the western edge of North America. Here lie the Cascades, a chain of volcanic peaks stretching from California to Washington. Mount St. Helens offered a stark reminder of their power in 1980, when its eruption levelled forests and darkened skies. Yet even now, its slopes are covered with new life, a testament to nature's resilience. Further north, in Alaska, the Aleutian Islands form a dramatic arc of volcanoes rising from the sea. Remote and windswept, these islands are constantly shaped by eruptions and earthquakes, a raw frontier where fire meets ocean. Crossing westward, the Ring of Fire bends toward Asia, and here the energy becomes even more concentrated. Japan sits squarely on this fiery boundary, its landscape defined by mountains and volcanoes that shape both its culture and its history. Mount Fuji, serene and symmetrical, is a cultural icon, though beneath its beauty lies the same restless force that powers all the peaks of the ring. The Japanese archipelago has endured countless eruptions and quakes, yet it has also flourished in their shadow, drawing on the fertile soils and hot springs born of volcanic energy. Further south, the Philippines and Indonesia mark perhaps the most volcanically active stretch of the ring. Indonesia alone is home to more than 100 active volcanoes, a staggering concentration unmatched anywhere else on Earth. Mount Merapi, Mount Bromo and Krakatoa are names woven into history and legend, each eruption shaping not only the land but also the people who live there. These islands, perched on the edge of tectonic turmoil, are forever remade by fire and ash, their lush landscapes growing from the very destruction that eruptions leave behind. Continuing eastward, the Ring of Fire arcs down to New Zealand, where the Taupo volcanic zone sits as one of the most dramatic volcanic regions in the world. Here, eruptions have reshaped landscapes on a colossal scale, leaving behind vast calderas and geothermal wonders. The lakes, geysers, and hot springs of New Zealand are visible reminders of the energy simmering beneath the ground. The Maori people wove this fiery landscape into their mythology, speaking of gods and guardians who shape the land through eruptions and earthquakes. What makes the Ring of Fire so captivating is not just its scale, but its variety. No two volcanoes are quite the same. Some erupt explosively, sending ash clouds high into the stratosphere, while others produce steady flows of lava that build islands over centuries. Some lie dormant for millennia before awakening, while others bubble and smoke continuously. Together, they form a tapestry of geological behaviour, a living laboratory where Earth's processes are laid bare. The Ring of Fire is also a place of contrasts. It gives with one hand and takes with the other. The same forces that destroy cities also create fertile soils, rich fisheries, and geothermal energy. The same earthquakes that topple buildings also uplift mountains and renew landscapes. Life along the ring is a constant negotiation between danger and reward. For countless generations, people have chosen to live within its reach, drawn by its abundance while mindful of its power. And though we often think of volcanoes as local phenomena, the Ring of Fire shows us that they are part of a planetary system. An eruption in Alaska can alter skies in Europe. A quake in Japan can send tsunamis racing across the Pacific to South America. This interconnectedness reminds us that Earth's geology does not respect borders. The Ring of Fire is not confined to one country or one culture. It is a shared inheritance of the planet itself. Yet despite the risks, there is a deep allure to these fiery coasts. People are drawn to the dramatic beauty of volcanic mountains, to the hot springs that bubble with mineral-rich waters, and to the stories passed down through generations. The Ring of Fire has given rise to myths of gods, dragons, and spirits, as humans sought to explain the restless earth beneath their feet. In truth, the reality is no less mysterious. A molten mantle rising, plates colliding, and fire-shaping land from ocean. When we look at a map of the Pacific with its sweeping arc of volcanoes and fault lines, we are looking at the beating heart of the planet. This ring is not just a boundary, but a pulse, a reminder that Earth is alive and still in motion. The continents, mountains, and islands we see today are not fixed, but part of an ongoing story written in fire. Travelling the ring of fire, even in imagination, is to glimpse the power and fragility of our world. It is to see coasts lifted from the sea, islands born from eruptions, and cultures shaped by landscapes both generous and threatening. It is to understand that the earth beneath us is never still, but always remaking itself, guided by the restless energy of volcanoes and the quiet but unstoppable movement of tectonic plates. The Ring of Fire is not simply a place, it is a lesson written across the Pacific, that destruction and creation are inseparable, that beauty and danger often share the same source, and that the Earth we know is still in the process of becoming. In its fiery embrace, we see both the risks of living on a restless planet and the wonders that make it endlessly fascinating. For early humans, volcanoes were not abstract geological concepts or distant curiosities. They were real and immediate presences, sometimes threatening, sometimes generous, and always impossible to ignore. Long before people wrote down stories, they lived in volcanic landscapes, shaping their daily lives around fire-breathing mountains and the gifts they provided. Volcanoes were destroyers, yes, but they were also suppliers of tools, sources of fertile land, and eventually figures in the myth that helped explain a world full of mystery. One of the most important gifts volcanoes gave to early humans was stone. Lava, once cooled, did not just harden into random rubble. Certain types of volcanic rock, especially obsidian, had qualities that made them invaluable for survival. Obsidian is a natural volcanic glass, formed when lava cools so quickly that crystals cannot form. The result is a shiny black stone that can be fractured into razor-sharp edges. For hundreds of thousands of years, humans chipped and flaked obsidian into cutting tools, arrowheads, and blades sharper than anything made of metal. In fact, even today, surgical scalpels crafted from obsidian edges are prized for their precision, sharper than steel at the molecular level. It is no exaggeration to say that volcanic stone was one of the earliest technologies that shaped human progress. Beyond obsidian, volcanic rocks of all kinds were used for grinding, pounding, and building. Basalt, with its toughness and durability, became a favourite for grinding stones and early construction. The availability of such resources meant that volcanic regions were not just dangerous, but desirable places to live. Even if a mountain might one day erupt, its presence gave humans the materials they needed to thrive. Volcanoes also influenced where people could grow food. As agriculture emerged thousands of years ago, fertile volcanic soils proved irresistible. The ashen minerals left behind after eruptions created ground so rich that crops flourished in abundance. In places like the Rift Valley in Africa, early humans found not only stone tools but also productive land to hunt and forage. Later, in regions such as Mesoamerica and Southeast Asia, volcanic soils supported dense populations and thriving early civilizations. The risk of eruption was balanced by the promise of harvest. But volcanoes were never only about practical gifts, they were also immense, awe-inspiring forces that demanded explanation. To watch a mountain glow red in the night, to hear it rumble like thunder, or to feel the ground tremble beneath one's feet must have seemed like the voice of something beyond human understanding. For people without the language of geology, volcanoes were alive, animated by gods, spirits, or ancestors. Myths grew naturally from these experiences, each culture weaving stories to make sense of the fire that could both sustain and destroy. Archaeological evidence suggests that humans were aware of and responding to eruptions far back in prehistory. In East Africa, layers of volcanic ash preserve footprints of early hominins, frozen in time for millions of years. These traces remind us that volcanoes were shaping landscapes and human experiences long before Homo sapiens even emerged. Later, as modern humans spread across the globe, they encountered volcanoes in almost every environment. Towering peaks in Africa, fiery islands in the Pacific, steaming vents in the Mediterranean. each encounter left an imprint on culture and imagination. For instance, obsidian trade networks extended vast distances, showing that volcanic gifts were not just local curiosities, but highly valued resources exchanged between groups. Pieces of volcanic glass have been found hundreds of kilometers from their sources, carried by people who understood its worth. This trade knit together early societies, spreading not just tools but also stories and connections. Volcanoes, in this sense, were silent participants in human networking, their stones travelling far beyond the mountains that birthed them. The danger of eruptions, of course, was never forgotten. Communities living near volcanoes would have witnessed forests burned, rivers dammed by lava, and skies darkened by ash. Survival depended on observation and adaptation. People learned to read the signs, the rumblings, the smoke, the smell of sulphur, and to flee when danger grew too great. Those who survived passed on their knowledge, and over time these warnings transformed into legends. Volcanoes became gods of fire, keepers of the underworld, or symbols of creation and destruction. They entered oral traditions, shaping the way people viewed the world itself. Even some of humanity's earliest artworks may carry volcanic inspiration. Spirals and flame-like motifs carved into rock could have been drawn from the sight of glowing lava flows. The dance of fire from the earth would have been both terrifying and mesmerizing, a spectacle etched into memory and passed through generations. Volcanoes were not just physical features of the landscape but emotional landmarks, shaping how humans understood power, danger, and renewal. Interestingly, living with volcanoes may also have shaped the paths of human migration. Some regions, though risky, were so rich in resources that they drew people repeatedly, even after devastating eruptions. The fertile valleys near Mount Vesuvius, the obsidian quarries of Anatolia, and the productive fields of Java all became centres of human settlement. Volcanoes pushed people away with one hand and pulled them back with the other, influencing where communities formed and how cultures developed. There is evidence that eruptions even left genetic echoes in humanity. The eruption of Mount Toba in Indonesia, one of the largest in human history, may have created a population bottleneck, reducing the number of humans to small groups. While scientists continue to debate the severity of its impact, it is possible that such an event shaped the course of our evolution, influencing who survived, where they migrated, and how they adapted. A single eruption may have left ripples in the very structure of our species. What is clear is that volcanoes were never mere backdrops to human history. They were active participants, providing tools, soils, and inspiration, while also demanding respect through their destructive power. Early humans lived with them in a relationship of awe and dependence, learning to harness their gifts while fearing their temper. That balance of reverence and reliance is a thread that continues through history and into the present day. When we think of human beginnings, we often imagine caves, rivers, and plains. Yet volcanoes were there too, shaping landscapes, supplying obsidian for blades, and inspiring stories told around fires. They were among the first forces to teach humans humility, to remind us that the world is not entirely ours to control, and in their paradoxical way, they gave us exactly what we needed to take our first steps towards civilization. The truth is, we are children of volcanoes as much as we are children of forests and rivers. The tools we used, the food we grew, the myths we told, and perhaps even the paths we walked were all influenced by fiery mountains. To live with volcanoes was to live with danger, but also with opportunity. They were not just looming threats, but companions in our earliest journeys. Even now, in every sharp edge of an obsidian arrowhead or in the fertile plains of volcanic soil, we can still see the quiet but undeniable role volcanoes played in human beginnings. Civilizations have always been drawn to volcanoes, a paradox that speaks volumes about the human spirit. On one hand, these mountains were unpredictable and dangerous, capable of unleashing devastation in moments. On the other, they offered some of the most fertile soils and abundant harvests on Earth. Time and again, people chose to settle in their shadows, accepting the risks for the promise of flourishing life. The story of civilizations and volcanoes is one of courage, opportunity, and sometimes tragedy, as fire and ash became both sustenance and threat. In the Mediterranean world, few volcanoes loom as large in memory as Vesuvius. Rising above the Bay of Naples, it was admired in Roman times as a handsome mountain. Its fertile slopes yielded grapes, olives, and grains, feeding bustling towns like Pompeii and Herculaneum. Farmers praised the richness of the soil, which owed its vitality to centuries of ash and lava deposits. For the Romans, the land seemed almost charmed, so productive that it appeared blessed by the gods. Yet beneath that prosperity, Vesuvius was alive, its fiery heart hidden from view. In the year 79, when it erupted with terrifying force, it buried the very towns that had thrived on its bounty. Pompeii and Herculaneum became ash-shrouded time capsules, a reminder that the same volcano that fed Roman vineyards could also erase entire communities in a single day. The Romans were not unique in their attraction to volcanic soils. Across the world, civilizations rose in landscapes enriched by fire. In Java, part of the Indonesian archipelago, volcanoes dominate the horizon. Towers of ash and lava, some of the most active volcanoes on the planet, have made the island both perilous and bountiful. For centuries, Javanese farmers have worked fields of rice nourished by volcanic minerals, producing harvests so abundant that the island became one of the most densely populated regions in the world. Temples such as Borobudur were built within sight of volcanic peaks, their stones testament to both reverence and reliance. Even when eruptions swept away villages, people returned, drawn by the enduring fertility of the soil. Further east, the civilizations of Central America also owed their prosperity to volcanoes. The Maya and later the Aztec farmed lands enriched by eruptions, growing maize, beans, and squash in abundance. The valleys of modern-day Guatemala and Mexico still reveal their volcanic origins, with ash layers embedded in the soil and mountains that continue to smoke. These societies did not merely endure volcanoes, they wove them into their cosmology. Deities of fire and mountains reflected both gratitude and fear, acknowledgement of the dual nature of volcanic power. For them, as for so many others, volcanoes were givers and takers, gods and monsters, friends and foes. The same paradox was evident in the highlands of Ethiopia. Here, volcanic soils nurtured the beginnings of agriculture that supported ancient kingdoms. Crops such as teff, a staple grain, thrived in the nutrient-rich ground. Further north, in regions like Anatolia, obsidian from volcanoes fueled trade networks stretching across early civilizations, providing not only tools but also a basis for economic exchange. The presence of volcanoes was more than geological. It was social, cultural, and economic, shaping how people lived and prospered. In Mesoamerica, one of the most striking examples is the Valley of Mexico, where the great city of Teotihuacan emerged. Surrounded by volcanoes such as Popocatépetl and Iztaccíhuatl, the valley was fertile and productive. The city grew to house perhaps 200,000 people at its height, supported by abundant harvests. The looming volcanoes were both protective guardians and sources of awe, their presence etched into the myths and rituals of the people. Even today, the volcanoes around Mexico City remain active, reminders of how closely the fortunes of civilizations have been tied to these restless mountains. Volcanoes did more than feed civilizations. They also shaped their identities. In Japan, Mount Fuji became more than a mountain. Its perfect cone, born of eruptions, inspired poets, artists, and pilgrims. Though not always destructive in recorded history, its presence was enough to symbolize endurance, beauty, and divine power. The Japanese recognized that the same forces that threatened villages also created landscapes of extraordinary elegance. The volcano was not just a geological feature but a cultural anchor, In Italy, Mount Etna played a similar role. Rising above Sicily, it has erupted countless times throughout human history, yet people have continually farmed its slopes. Vineyards and orchards thrive in its soils, producing wines and fruits of renowned quality. For Sicilian communities, Etna is both a challenge and a provider, a reminder that life near a volcano requires resilience and adaptation. The legends of Hephaestus, the god of fire working his forge beneath Etna, reflect the sense that this mountain was alive, shaping not just the land but human imagination. Even in the modern era, the relationship between civilizations and volcanoes persists. Cities like Naples, Mexico City and Quito continue to grow in the shadows of active volcanoes. People know the risks, but the fertility of the land, the availability of water and the beauty of the landscapes are powerful lures. Scientists monitor these volcanoes carefully, but the draw of their fertile soils remains as strong as it was in ancient times. Humanity has always been willing to gamble with fire when the rewards are so rich. What unites these stories is a pattern of resilience. Civilizations have flourished where volcanoes gave them fertile ground, and when eruptions came, they endured, rebuilt, and carried on. Volcanoes became part of their identity, woven into myths, rituals, and daily life. The danger was real, but so too was the abundance. Time and again, people chose to live not in fear, but in balance, adapting to the rhythms of fire. There is a certain poetry in this arrangement. Volcanoes destroyed, but they also created. They buried, but they also nourished. The civilizations that grew in their shadows were testaments to humanity's ability to find opportunity in risk, to transform danger into possibility. From Roman vineyards to Javanese rice fields, from Mesoamerican temples to Japanese shrines, volcanoes stood as silent partners in human progress. When we think of the great civilizations of the past, we often picture monuments, rulers, and battles. Yet beneath it all, there was soil, rich, dark, volcanic soil, fed by ash and lava, ready to sustain life. Without it, the story of humanity might have been very different. Volcanoes, with all their contradictions, were midwives to civilizations, offering both abundance and humility. They reminded people that the earth itself was alive, and that prosperity often comes at the edge of danger. In the end, civilizations did not simply survive volcanoes, they thrived because of them. They built homes, fields, and temples in volcanic landscapes, turning fire into harvest and ash into sustenance. The pattern is as clear today as it was thousands of years ago. Where volcanoes breathe, life follows, bold enough to risk everything for the rewards they offer. Civilizations, in their grandeur and fragility, are living proof of humanity's enduring bond with the restless mountains of fire. Since the first humans watched a mountain split open and pour fire into the sky, volcanoes have been more than geological events. They have been visions of the divine, signs of anger, and reminders of powers beyond human control. Across cultures and ages, volcanoes have entered the imagination as homes of gods, lairs of demons, and instruments of punishment. Their smoke, their thunderous rumbles, and their rivers of fire demanded explanation, and so myths were born. Myths that tell us as much about the people who created them as they do about the fiery mountains themselves. In ancient Greece, the volcanoes of the Mediterranean were linked to the forge of Hephaestus, the god of fire and craftsmanship. The island of Volcano, whose name would later inspire the word volcano itself, was said to be his workshop. The glowing craters and the smell of sulphur were explained as the smoke and sparks of his celestial smithy, where he hammered weapons for gods and heroes alike. Mount Etna in Sicily was imagined as another of his forges, with its tremors and eruptions caused by the clanging of hammers on divine anvils. To the Greeks, these mountains were not just natural features but doorways to the realm of gods, a place where human and divine worlds overlapped. The Romans inherited these ideas, and with them came the stories of divine punishment. When Vesuvius erupted in the year 79, entombing Pompeii and Herculaneum, survivors and witnesses saw it not only as a natural disaster, but as wrath from above. The booming of the eruption sounded like the anger of Jupiter, the lightning and ash as if hurled from the hands of gods. For Romans steeped in omens and portents, the destruction of entire towns seemed proof that the divine powers could smite with mountains themselves. Far across the world, in the Pacific Islands, volcanoes were seen not only as gods but as ancestors. In Hawaiian tradition, Pele, the goddess of fire, is one of the most powerful and revered figures. She is said to live in the Halema Uma'u crater at the summit of Kilauea, shaping the land with her lava flows. Her eruptions were not random but expressions of her will, sometimes acts of creation, building new land, sometimes acts of destruction, consuming villages and forests. Islanders told stories of her temper, her generosity, and her battles with other deities. Even today, offerings are left to Pele, a recognition of her enduring presence in the landscape. In Japan, Mount Fuji holds a different place in the cultural imagination. Perfect in its symmetry, it was seen not as a place of wrath, but as a sacred mountain touched by the divine. Though a volcano, its eruptions were less central to its myth than its beauty and majesty. It became a symbol of endurance, purity, and the connection between earth and heaven. Pilgrims climbed its slopes to draw closer to the gods, and artists captured its image as a vision of harmony. Here the fire mountain became less about fear and more about reverence, a silent reminder of the sacred woven into the natural world. Among the Maori of New Zealand, volcanoes were entwined with legends of conflict and love. The volcanic peaks of the North Island, such as Tongariro, Ngauruhoe, and Taranaki, were imagined as living beings, warriors who fought for the love of the beautiful mountain. Their battles were fierce, reshaping the land as they moved and clashed. Valleys and rivers were explained as the scars of their struggles, and eruptions as the lingering expression of their passions. For the Maori, volcanoes were alive, their stories written into the very shape of the land. In Central America, the civilizations of the Maya and the Aztecs saw volcanoes as sacred thresholds between worlds. The smoking peaks of Mexico, Popocatépetl and Iztaccíhuatl, were imagined as lovers frozen in stone, their fiery hearts still alive. Eruptions were interpreted as the restless stirrings of gods, reminders that humans lived at their mercy. Rituals and sacrifices were performed to appease these powers, to keep the balance between life-giving soil and life-taking fire. In Norse tradition, where fire and ice define the cosmic landscape, volcanoes may have been seen as portals to Muspelheim, the fiery realm of giants. The eruptions of Iceland and the glowing flows of lava would have seemed like the breath of Surt, the fire giant destined to bring about the end of the world at Ragnarök. In this vision, volcanoes were not just local hazards, but cosmic players in the ultimate fate of gods and men alike. What unites these myths, from Greece to Hawaii, from Japan to Central America, is the recognition that volcanoes embody forces beyond ordinary human experience. They shake the ground, darken the skies, and pour rivers of fire. To ancient peoples, these were not natural processes but communications from realms beyond. Whether seen as divine forges, fiery goddesses, quarrelling mountains, or punishments from the heavens, volcanoes entered human stories as symbols of creation, destruction, passion, and justice. These myths also reveal an attempt to find meaning in unpredictability. Volcanoes erupt without warning, sometimes after centuries of silence. They destroy with little regard for human plans or settlements. To explain such capriciousness, cultures personified volcanoes, giving them tempers, desires, and wills. In doing so, they made the incomprehensible slightly more understandable. If a volcano was angry, one could appease it. If it was generous, one could thank it. Myths gave people a way to live with forces they could not control. Even in more recent times, volcanic eruptions have inspired interpretations beyond the geological. The Great Eruption of Tambaya in 1815 which caused the year without a summer, was read by some as divine punishment. Ash clouds that blotted out the sun and crop failures that led to famine seemed apocalyptic, reminders of humanity's fragility. Though scientists now explain the climate effects in terms of aerosols and atmospheric circulation, the instinct to see meaning in the fire of mountains remains deeply human. Volcanoes also shaped ritual. Around the world, offerings of food, animals, and even humans were made to appease the gods of fire. Altars were placed on volcanic slopes, prayers uttered to calm the mountains. The presence of fire within the earth demanded acknowledgement. It was too powerful to be ignored. These rituals were not simply superstition, but reflections of a relationship, an understanding that life was lived at the mercy of fire and that gratitude and respect were necessary to survive. Today we may explain volcanoes in terms of magma chambers, tectonic plates, and geochemistry, but the myths still linger. Tourists in Hawaii still hear the stories of Pele. The silhouette of Mount Fuji remains a sacred image in Japan. The ruins of Pompeii still whisper of gods and punishment. Myths endure because they capture not just the fear, but also the wonder of living with volcanoes. Volcanoes are more than mountains. They are storytellers, shaping landscapes and inspiring imaginations. For early cultures, they were proof that the earth was alive, that it had moods, tempers, and intentions. Myths, gods, and fire mountains remain bound together, part of a long human attempt to make sense of a planet that breathes fire from its depths. Whether worshipped, feared, or revered, volcanoes have always been more than stone and lava. They have been mirrors of our own need for meaning and symbols of the power that forever humbles us. Volcanoes have always carried a double face. On one side, they offer fertile soils, rich minerals, and landscapes that sustain civilizations. On the other, they remind us with chilling force that their generosity is matched by their power to destroy. When they erupt violently, the results are often catastrophic, wiping away towns, altering climates, and reshaping the course of history. The stories of Pompeii, Krakatoa, and Tambora are among the most haunting reminders of the dark side of volcanoes, moments when fire overwhelmed human resilience, leaving both scars and lessons behind. Pompeii is perhaps the most famous example of a volcanic disaster etched into cultural memory. In the year 79, Mount Vesuvius erupted with a fury that no Roman could have imagined. At first, the mountain released a towering column of ash and pumice, rising high into the sky and raining debris on the surrounding towns. Residents of Pompeii struggled under the weight of falling stone, roofs collapsed and streets disappeared under ash. Then came the pyroclastic surges, fast-moving avalanches of hot gas and rock that swept through the city, suffocating and burying those who had not fled. In a matter of hours, Pompeii and its neighbour Herculaneum vanished beneath layers of volcanic material. For centuries these towns lay hidden, until excavations revealed them as frozen moments in time. Streets, villas, shops, and even the bodies of people caught in their final moments were preserved in remarkable detail. Today Pompeii is both a window into Roman life and a sombre reminder of how quickly a volcano can erase an entire society. The same fertile soils that had supported vineyards and olive groves were also the reason people lived so close to danger. In the end, prosperity and catastrophe were two sides of the same volcanic coin. If Pompeii shows us destruction on a local scale, Krakatoa demonstrates what happens when a volcano alters the world itself. In August of 1883, the island of Krakatoa in Indonesia erupted with an intensity so great that the explosions were heard as far away as Australia and even across the Indian Ocean. Entire portions of the island collapsed into the sea, creating tsunamis that swept across coastlines and killed tens of thousands of people. The eruption produced shockwaves that circled the globe multiple times, while ash injected into the atmosphere dimmed sunlight and created spectacular red and orange sunsets for years. Painters like Edvard Munch are thought to have captured these eerie skies in works such as The Scream. the sheer force of Krakatoa's eruption demonstrated how interconnected the world is under the influence of volcanoes. What began as a single event in Indonesia altered weather patterns, disrupted agriculture, and filled the skies with ash from the tropics to Europe. It was one of the first volcanic disasters to be reported globally, as telegraphs carried the news across continents within hours. Humanity was confronted with the truth that volcanoes are not merely local threats. They can be planetary events, rewriting skies and reshaping climates. Yet even Krakatoa, devastating as it was, pales beside the eruption of Mount Tambora in 1815. Located on the island of Sumbawa in Indonesia, Tambora erupted with a force unmatched in recorded history. Its explosion blasted more than 100 cubic kilometers of material into the air, reducing the once towering mountain by more than a kilometer in height. Tens of thousands of people were killed directly by the eruption and the tsunamis it unleashed, but its greatest impact came afterward, in the form of a volcanic winter. Ash and sulfur dioxide from Tambora spread into the stratosphere, where they reflected sunlight away from Earth. The result was a dramatic cooling of global temperatures. 1816 became known as the year without a summer. In Europe and North America, crops failed under frosts and unseasonal snowstorms. Famine spread, food prices soared, and communities were pushed to desperation. In New England, farmers gave up their lands and migrated westward in search of better conditions. In Europe, the misery inspired both social unrest and works of art. Mary Shelley, trapped indoors by the cold and gloom, began to write Frankenstein, a novel that reflected the dark mood of the time. The eruption of Tambora shows us how a volcano can reach across the world, shaping history in unexpected ways. It reminds us that the fate of civilizations can hinge not only on human choices, but on the restless breath of mountains half a world away. While Pompeii revealed the vulnerability of towns, and Krakatoa stunned the world with its sound and spectacle, Tambora reshaped entire societies through hunger and hardship. But the dark side of volcanoes is not only about death and loss, it is also about survival and adaptation. In every case, humans eventually return to these volcanic landscapes, drawn once more by their fertility and beauty. The slopes of Vesuvius are still home to vineyards and farms. The islands near Krakatoa are repopulated, their forests regrown, their soils rich with nutrients from the eruption. Even Tambora's scarred land supports villages today, where farmers cultivate crops in the very soil created by the explosion. People continue to live with volcanoes because the same forces that destroy also renew. These disasters also spurred advances in science and awareness. The study of Pompeii gave archaeologists unprecedented insight into Roman life, while the global reporting of Krakatoa highlighted the need for international cooperation in monitoring natural disasters. Tambora, with its far-reaching climate effects, helped scientists understand the link between volcanic eruptions and global weather patterns. Tragedy forced humanity to learn, to respect the scale of volcanic power, and to seek ways of predicting and preparing for future eruptions. In the cultural memory, volcanoes have become symbols of fragility and resilience. They remind us that civilizations, no matter how advanced, remain subject to the rhythms of the earth. They teach us that survival often depends on humility, on recognizing that we're not masters of nature, but participants in a larger, unpredictable system. Pompeii's streets, Krakatoa's sunsets, and Tambora's famines all carry the same lesson. The earth is alive, and we live at its mercy. It is tempting to view these stories with fear, but they also hold wonder. The preservation of Pompeii is as miraculous as it is tragic. The sunsets painted by Krakatoa's ash were eerie but beautiful. The migrations and innovations sparked by Tambora reshaped societies in ways that still echo today. Even in their darkest moments, volcanoes leave behind legacies that stretch beyond destruction, shaping culture, art, and human destiny. The dark side of volcanoes, then, is not only about devastation but about transformation. They can erase, but they also create. They devastate, yet they teach. Each eruption that has scarred humanity has also reminded us of our resilience, our adaptability, and our deep connection to the restless earth. Volcanoes are both peril and promise, and in their shadow, humanity has learned to endure, rebuild, and, in some strange way, even flourish. When people think of volcanoes, they often imagine fiery eruptions and rivers of lava. But volcanoes are not only local spectacles of destruction and renewal, they are also global players, quietly shaping the climate of the planet over immense spans of time. By exhaling gases into the sky, volcanoes have acted as regulators of Earth's thermostat, sometimes plunging the world into cold, sometimes warming it, and always reminding us that the climate is bound to the deep rhythms of fire beneath the crust. Every eruption is, in essence, an atmospheric experiment. When a volcano releases sulfur dioxide into the stratosphere, the gas reacts with water to form fine particles of sulfuric acid. These aerosols can linger high above the Earth for years, reflecting sunlight back into space and cooling the surface below. The result is what scientists call a volcanic winter, a temporary dimming of the sun that can shift weather patterns across continents. A single eruption can cool the planet for a few years. Multiply that effect by the countless eruptions over millions of years, and you begin to see how volcanoes have helped steer Earth's climate in the long run. The eruption of Tambora in 1815 offers a vivid example. By lofting massive amounts of sulfur into the atmosphere, Tambora triggered a year without a summer. Crops failed in North America and Europe, famines spread, and strange cold weather became the norm. Yet this was just a glimpse of what volcanoes can do. Larger and more sustained eruptions throughout history have likely altered the trajectory of entire eras. During the 14th century, for example, a cluster of eruptions may have contributed to the onset of the Little Ice Age, a period of cooler temperatures that reshaped agriculture and societies across the Northern Hemisphere. But volcanoes do not only cool the world, over deep geological time they have also warmed it. The key player here is carbon dioxide, released in vast amounts from volcanic vents. While sulfur aerosols fade within years, carbon dioxide lingers in the atmosphere for thousands or even millions of years. During times of intense volcanic activity, when massive eruptions blanketed continents in lava flows, carbon dioxide levels in the atmosphere soared, trapping heat and warming the planet. This was the case during the outpouring of the Siberian Traps about 250 million years ago, an event linked to catastrophic warming and the greatest mass extinction in Earth's history. The balance between these two effects, short-term cooling from sulfur and long-term warming from carbon dioxide, is what makes volcanoes such powerful climate players. They are not simply destructive, they are regulators, tuning the climate in ways that have shaped life's entire story. Without volcanic outgassing, the atmosphere would gradually lose its carbon dioxide, absorbed by rocks and oceans, and the Earth might freeze into a snowball. Without eruptions replenishing greenhouse gases, our world would be lifeless ice. Fire, paradoxically, has kept the planet habitable. Over the span of billions of years, volcanoes have created a feedback system that works like a thermostat. When carbon dioxide levels fall too low, weathering of rocks slows, allowing volcanic emissions to build the gas back up. When levels grow too high, warming increases rainfall and weathering, drawing carbon dioxide back down into rocks and oceans. This natural balance, known as the carbonate-silicate cycle, is why Earth has maintained liquid water and relatively stable temperatures despite changes in the sun's brightness. It is a planetary-scale balancing act, with volcanoes as one of the key players. It is humbling to realise that while volcanoes may seem unpredictable in the moment, their role in Earth's climate has been remarkably steady. For billions of years, they have breathed out gases that maintain the balance necessary for life. They have also provided the disruptions that forced evolution to adapt, the sudden coolings and warmings that reshaped ecosystems. Without volcanic control over climate, life's path would likely have been far narrower. its possibilities far fewer. The effects of volcanoes on climate can also be seen in smaller human-scale history. The eruption of Lerki in Iceland in 1783 poured sulfur dioxide into the atmosphere, creating a haze that cooled Europe and contributed to widespread crop failures. Famines followed, and some historians argue that the social unrest it triggered played a role in the French Revolution. Here again is the quiet reminder that climate, politics, and volcanoes are all linked in ways that may not be obvious until hindsight reveals the chain of cause and effect. In the oceans, volcanic influence on climate is even more profound. Submarine eruptions along mid-ocean ridges release heat and gases directly into seawater, influencing currents and chemistry. While these eruptions are less dramatic than those on land, their sheer scale makes them crucial players in the carbon cycle. Some scientists believe that pulses of undersea volcanic activity have contributed to long-term climate cycles, subtly nudging the Earth toward warm or cool periods. The ocean, vast and slow to change, carries the fingerprints of volcanic rhythms deep in its currents. Even ice ages, those long frozen episodes in Earth's history, may have been influenced by volcanoes. During periods of low volcanic activity, when less carbon dioxide was released, the planet cooled enough for ice sheets to spread. Conversely, bursts of volcanic outpouring may have helped end these icy stretches, flooding the air with greenhouse gases that warmed the world again. In this way, fire has repeatedly melted ice, ensuring that Earth never remained frozen forever. Looking outward, other planets remind us of the importance of this balance. Mars, once volcanic, lost its atmosphere when its eruptions dwindled. With no steady outgassing to replenish carbon dioxide, the planet froze into a cold desert. Venus, by contrast, may have experienced runaway volcanic emissions that thickened its atmosphere to crushing levels, creating a furnace world. Earth alone seems to have struck the balance, thanks to the long game played by volcanoes and the cycles of rock, water, and air they sustain. There is an irony in how we think of volcanoes. To us, they are violent, disruptive, and chaotic. Yet on a planetary scale, they are steady guardians of climate, ensuring that temperatures stay within a narrow band suitable for life. Their eruptions may terrify in the short term, but over millions of years, they are the reason forests can grow, oceans can remain liquid, and humans can gaze at the sky without freezing or burning. The long game of volcanoes is still being played. Today, scientists monitor not only eruptions but also the gases seeping quietly from volcanic landscapes. These emissions, though invisible, are part of the same process that has shaped climate since Earth's birth. They remind us that the thermostat of the planet is not controlled by humans alone, but by forces deep beneath the crust. In every breath of air and in every drop of water there is a trace of volcanic influence. Our world's climate is not an accident, but the product of cycles that fire has fueled for eons. Volcanoes may appear to erupt by chance, but their role in Earth's history has been consistent, to keep the balance between warmth and cold, between ice and ocean, between lifelessness and abundance. When the ground trembles or the sky fills with ash, it is easy to see volcanoes only as threats. Yet their deeper story is one of guardianship, a patient stewardship that has made Earth the only known world with oceans, clouds, and living forests. Volcanoes, in their fiery exhalations, have been the quiet caretakers of climate, keeping the planet's thermostat tuned across the ages. In the end, the long game of fire is the reason our world remains alive. To live with volcanoes is to live with uncertainty. They can slumber for centuries, disguised as peaceful mountains, only to roar back to life with little warning. For much of history, eruptions seemed beyond understanding, acts of gods or demons rather than processes of geology. Today, though, we have a field dedicated to reading the moods of these fiery giants. Volcanology. It is the science of volcano watching, a blend of calm precision, daring fieldwork, and the occasional dash of luck. Volcanologists in their quiet way are translators, listening to the language of the earth and trying to make sense of what it is saying. At its heart, volcanology is about patterns. Volcanoes rarely erupt out of nowhere. They rumble, they shift, they exhale gases, and they sometimes even bulge as magma pushes toward the surface. Volcanologists study these signals with an array of instruments designed to catch every twitch and sigh. Seismographs, for example, are used to detect earthquakes beneath volcanoes. When magma rises, it cracks the rock, creating swarms of tiny tremors. By mapping these quakes, scientists can trace the path of magma and estimate whether it is heading toward an eruption. It is a little like listening to footsteps in the dark and guessing whether someone is walking toward the door or just pacing around inside. Another clue lies in the gases that volcanoes breathe out. As magma moves upward, it releases water vapor, carbon dioxide, sulfur dioxide, and other gases. The ratios of these gases can reveal what is happening underground. A sudden surge of sulfur dioxide, for instance, may signal that magma has reached shallower depths. To measure these emissions, scientists sometimes stand near volcanic vents with portable instruments, carefully collecting samples from the steaming ground. At other times, they let technology do the job, sending drones or satellites to sniff out volcanic gases from a safe distance. The work can be dangerous, but it is also oddly intimate, like checking the breath of a restless mountain. Then there is the shape of the volcano itself. With satellites and ground-based instruments, volcanologists measure even the smallest changes in slope. If the mountain begins to swell or tilt, it may mean magma is accumulating beneath. A bulge of just a few centimeters can be enough to alert scientists that pressure is building. These subtle changes are often invisible to the eye, but when tracked over time, they tell a story of deep processes unfolding beneath the crust. Despite all this precision, volcano watching is not an exact science. Volcanoes are moody, and they do not always follow predictable patterns. Sometimes they rumble and swell for weeks, then fall silent without erupting. Other times, they seem quiet until they explode with little warning. Volcanologists joke that volcanoes like to keep their secrets, revealing only what they choose. The challenge is to interpret the clues without assuming too much, to prepare people for possible danger while acknowledging that the Earth does not run on human schedules. The history of volcanology is full of daring individuals who ventured close to danger in pursuit of understanding. In the 18th and 19th centuries, scientists climbed the slopes of Vesuvius and Etna, sketching eruptions and measuring lava flows with little more than notebooks and bravery. In the 20th century, married couple Maurice and Katia Kraft became famous for their spectacular footage of eruptions, often standing alarmingly close to lava fountains and pyroclastic flows. Their passion brought the beauty and danger of volcanoes to the public eye, though, tragically, they were killed during an eruption in Japan in 1991. Their legacy, however, inspired a new generation of scientists and reminded the world of the delicate balance between curiosity and caution. Modern volcanology relies as much on technology as on daring fieldwork. Satellites orbiting Earth now provide continuous monitoring of active volcanoes, tracking thermal anomalies, gas emissions, and surface deformations from space. Drones fly where humans cannot, sampling gases from erupting craters or filming lava flows with remarkable precision. Networks of sensors relay real-time data to research centres, where scientists analyse patterns and issue alerts. In this way, volcano watching has become a global effort, with information shared between countries to protect lives. A restless volcano in Alaska, for example, is monitored as carefully as one in Indonesia, because the ash plumes it releases can threaten aircraft across entire hemispheres. For all the seriousness of the work, volcanologists often approach their subject with a sense of humour. It is hard not to, when your daily task involves watching a mountain that could explode at any moment. Some researchers joke that volcanoes are like toddlers throwing tantrums, noisy, messy and unpredictable, but still oddly lovable. Others compare monitoring equipment to stethoscopes pressed against the chest of a giant patient. The lightheartedness is not disrespectful. It is a way of coping with the awe and danger of studying forces that are far beyond human control. The practical value of volcanology is enormous. By monitoring signs of unrest, scientists can provide warnings that save lives. Before Mount Pinatubo erupted in the Philippines in 1991, careful observation of seismic activity and gas emissions allowed authorities to evacuate tens of thousands of people. Though the eruption was massive, the death toll was far lower than it might have been. This was a triumph of science and preparedness, showing that volcano watching can make the difference between disaster and survival. Yet even with the best technology, there are limits. Some volcanoes erupt with little warning, and predicting the exact timing and scale of an eruption remains one of geology's greatest challenges. Still, progress is steady. Every eruption studied adds to the body of knowledge, refining models and improving forecasts. In this sense, volcanoes are both teachers and tests, pushing scientists to learn more with every outburst. The fascination with volcanoes goes beyond safety. They're also keys to understanding how our planet works. By studying volcanic rocks, scientists uncover the chemistry of Earth's mantle, the hidden layer that drives plate tectonics. By analysing ancient ash deposits, they reconstruct past climates and trace the influence of eruptions on human history. Volcanology is not just about watching eruptions. It is about listening to the Earth's long memory written in stone and fire. There is a quiet poetry in the work. To sit at a monitoring station, listening to the subtle rumblings of a volcano, is to hear the pulse of the planet. To watch a satellite image of glowing lava is to glimpse Earth's inner fire escaping into the open. The data may be plotted in neat graphs and equations, but behind it lies something vast and mysterious. The reminder that we live on a world that is still alive, still breathing, still shaping itself in fire. In the end, volcanologists are not so different from ancient storytellers who saw gods in the mountains. Both sought to understand and explain what they witnessed. The difference is that modern volcano watchers have tools of science rather than myths, graphs instead of legends. But the sense of awe remains the same. Volcanoes inspire respect, caution, and wonder in equal measure. Volcano watching, then, is more than a science. It is a dialogue between humanity and the Earth, a constant attempt to read signals from the deep. It blends precision with humility, seriousness with humour, and danger with discovery. And while no instrument can predict every eruption, the effort itself is a testament to our desire to understand the fiery heart of the world we call home. In their rumblings, volcanoes speak a language of stone and gas. Thanks to the patience of volcano watchers, we are beginning, at last, to hear what they have been saying all along. Volcanoes are not just an earthly phenomenon. They are one of the universe's most common ways of reshaping worlds, a universal expression of planetary energy. Wherever there is heat trapped beneath a crust, whether from radioactive decay, tidal forces, or lingering warmth from formation, there is the possibility of volcanoes. They may not always look like the fiery mountains we know, but they share the same essence. Places where a planet or moon breathes out its interior, rewriting its surface in the process. By looking outward, we find that volcanoes are builders not only of Earth, but of many worlds scattered across the solar system. Take Io, one of Jupiter's moons, often described as the most volcanically active body in the solar system. Io is constantly being stretched and squeezed by Jupiter's immense gravity and the pull of neighbouring moons. This relentless tidal heating keeps its interior molten, producing a world where eruptions never seem to end. Plumes of sulphur and lava fountains rise hundreds of kilometres into space, while rivers of molten rock sprawl across the surface. To us, Io would look like a hellish landscape painted in yellows, reds and blacks, scarred by continuous eruptions. Yet in this chaos lies beauty. Volcanoes here are not rare disasters but constant features, endlessly remaking the moon's surface. If Earth's volcanoes seem dramatic, Io makes them look tame by comparison. Mars tells a different volcanic story. The red planet is home to Olympus Mons, the tallest volcano in the solar system. Standing nearly 22 kilometers high, it is about 3 times taller than Mount Everest and so wide that it would cover the entire state of Arizona. Unlike the restless eruptions of Io, Olympus Mons and other Martian volcanoes are now extinct. Their immense size was made possible by the absence of plate tectonics on Mars. On Earth, plates move over hotspots, creating chains of volcanoes like Hawaii. On Mars, the crust did not move, so a single hotspot could keep building in the same place for millions of years, producing mountains that dwarf anything on Earth. Though silent now, these giants are monuments to a time when Mars was alive with fire, reshaping the planet's surface and perhaps influencing its once warmer, wetter climate. Venus offers yet another variation on volcanic worlds. Its surface is hidden beneath thick clouds of carbon dioxide and sulfuric acid, but radar mapping has revealed vast volcanic plains, shield volcanoes, and features called coronae, circular structures formed by upwelling magma. Evidence suggests that much of the surface of Venus has been resurfaced by massive volcanic events within the last few 100 million years. Some scientists even suspect that Venus may still host active volcanoes, quietly erupting beneath its suffocating atmosphere. If true, these eruptions could help explain the planet's extreme climate. Venus is a world where volcanic gases, particularly carbon dioxide, built a runaway greenhouse effect, trapping so much heat that its surface is hot enough to melt lead. Here, fire did not just build the land, it transformed the air into a choking shroud. Beyond the rocky planets and moons, the outer solar system offers more exotic forms of volcanism. On Neptune's moon, Triton, and Saturn's moon Enceladus, eruptions take the form of icy geysers. Instead of molten rock, these cryovolcanoes spew water, ammonia, and methane into space. Enceladus, in particular, has captured imaginations with its plumes of water vapour erupting from cracks near its south pole. Beneath its icy crust lies a global ocean, kept liquid by tidal heating. The geysers deposit material onto Saturn's E-ring and hint at the possibility of life sheltered in the hidden seas below. Here, volcanism does not produce mountains of fire but fountains of ice, yet the principle is the same. A world expressing its interior heat by venting it outward. Triton's cryovolcanoes are even stranger, powered by seasonal heating as sunlight warms its frozen nitrogen surface. Dark plumes rise kilometers into the thin atmosphere, drifting across the icy plains. It is a reminder that volcanism is not limited to molten rock. Wherever a material can melt, vaporize, and erupt under pressure, volcanoes can exist, whether of fire, ice, or something more exotic. Even distant Pluto shows signs of volcanic activity. NASA's New Horizons mission revealed large dome-like structures that appear to be cryovolcanoes, possibly erupting slurries of water and ice in the recent past. In this frozen frontier, volcanism may be one of the few processes still reshaping the surface, a faint echo of the restless fire that defines more massive worlds. The universality of volcanoes raises profound questions. If volcanic activity is so widespread in our own solar system, what about the countless exoplanets orbiting distant stars? Many of these worlds are larger than Earth, with thicker atmospheres and stronger gravitational forces. Some are rocky, super-Earths. Others are icy bodies orbiting close to their suns. It is almost certain that many of them experience volcanic activity, whether fiery or icy, visible or hidden. On some, volcanoes may be shaping atmospheres in ways detectable from afar, offering clues to their composition and perhaps even their habitability. Volcanoes, wherever they occur, are more than geological curiosities. They are engines of transformation. They build land, shape climates, and provide energy and nutrients. On Earth, they may have helped spark life, On icy moons like Enceladus or Europa, cryovolcanoes may create the conditions for alien microbes to thrive. Even on hostile Venus, they remind us of how planetary atmospheres can be dramatically altered. To study volcanoes beyond Earth is to glimpse the processes that make worlds into what they are, from habitable oases to infernos. There's also a certain comfort in knowing that Earth is not alone in its fiery restlessness. The glow of lava on Io, the silent bulk of Olympus Mons, the icy plumes of Enceladus, all of these remind us that volcanism is not a quirk of our planet, but a universal language of worlds. It is how planets breathe, how they express their inner heat, and how they evolve over time. When we gaze at the night sky, it is easy to think of space as cold and still. Yet scattered among the stars are countless planets and moons alive with volcanic activity, reshaping their surfaces even as we watch from afar. Some erupt in fire, others in ice, but all are bound by the same principle, the restless need of worlds to release their energy. Volcanoes are universal builders, storytellers in stone and steam, revealing that the drama of fire and eruption is not confined to Earth, but written across the cosmos. In the end, alien volcanoes remind us of our shared planetary heritage. Whether on Io, Mars, Venus, or distant icy moons, the language of fire and eruption echoes across the solar system. To study them is to understand not just the geology of other worlds, but the deep truth that creation and destruction, heat and renewal, are cosmic constants. Our planet's volcanoes are part of a much larger story, one where fire and ice alike build the worlds that drift quietly through the dark. Volcanoes have been with Earth since its fiery beginnings, and they will remain long after our age has passed. They are not brief actors on the stage of time, but enduring forces that shape continents, steer climates, and influence life in ways both dramatic and subtle. To imagine Earth's future is in part to imagine the future of volcanoes, because as long as the planet retains its inner heat, fire will continue to find its way to the surface. The question is not whether volcanoes will still matter, but how they will write the next chapters of Earth's story. One certainty is that continents will keep drifting, driven by the restless conveyor belt of plate tectonics. As they shift, volcanoes will move with them, rising where plates collide or pull apart. The Pacific Ocean, for instance, will not remain as it is today. Over tens of millions of years, its vast basin will shrink as plates dive beneath Asia and the Americas, feeding fiery arcs of volcanoes that will build new mountains and islands. The familiar ring of fire will change shape but will not disappear. It will simply redraw itself, erupting in new places as the continents shuffle. Perhaps one day, long after human maps are forgotten, a new supercontinent will gather, and along its edges volcanoes will thunder as the planet welds itself back together. Super eruptions, rare though they are, will almost certainly occur again. Yellowstone, Toba, Taupo. These are not ancient legends, but living systems that will one day awaken. Whether it is in 10,000 years or 1 million, the Earth's pressure will build until another colossal eruption reshapes skies and climates. Such events are reminders that the planet plays the long game. They do not occur on human timescales, but in the sweep of geological history they are as certain as the tides. When they come, they will test the resilience of whatever life and civilizations exist then, reminding them of the humility required to live on a restless world. Yet volcanoes are not only harbingers of destruction, they will continue to be builders. Even now, new islands rise from the seas, small at first, then eroded or expanded by repeated eruptions. Over millions of years, chains of islands may merge into larger land masses, offering fresh homes for life. Under the oceans, ridges will keep producing new crust, feeding hydrothermal vents where strange ecosystems flourish in eternal night. As long as heat flows from Earth's core, these hidden factories will hum, ensuring that the deep sea remains alive with microbial chemists and their peculiar communities. Climate too will remain under volcanic influence. Eruptions large enough to inject sulfur into the stratosphere will continue to bring temporary cooling, perhaps even offsetting warming trends in the short term. Over longer spans, steady volcanic outgassing of carbon dioxide will keep replenishing the atmosphere, balancing the slow removal of carbon by rocks and oceans. Without this quiet exhalation, Earth might eventually freeze. With it, the planet's thermostat will remain set within the band that allows liquid water, at least until the sun grows too bright. Volcanoes are, in a very real sense, guardians of habitability, their fiery breath sustaining conditions suitable for life. Life itself will continue to adapt around volcanoes, as it always has. Forests will regrow on slopes stripped bare by lava. Grasses will colonize fresh ash fields. Animals will learn to live in landscapes that shift and burn, just as humans have done for millennia. Evolution has always found opportunity in volcanic upheaval, and it will do so again. New species may one day evolve in the unique niches of volcanic soils, hot springs and fuming craters, just as microbes did billions of years ago. Far into the future, life may even owe its survival to volcanic refuges, where heat and chemistry persist during times of planetary change. On a cosmic timescale, however, Earth's volcanism will not last forever. The planet's interior is slowly cooling, its supply of radioactive heat dwindling. Hundreds of millions of years from now, eruptions will become less frequent, the crust stiffer, the fires dimmer. Earth may begin to resemble Mars, its once vibrant volcanism reduced to silence. By then, however, the sun itself will have grown hotter, slowly boiling the oceans and transforming the climate beyond recognition. In this distant age, the last volcanoes may erupt under skies that no longer resemble those we know, exhaling one final plume before fading into memory. But that is a far horizon. In the nearer future, measured in thousands or even millions of years, volcanoes will remain central to Earth's story. Super eruptions will darken skies, new islands will rise, continents will fracture and collide, and life will adapt as it always has. Humanity, if it endures, will face the challenge of living with these fiery companions, perhaps even harnessing them more fully. Already, geothermal energy provides clean power from volcanic heat. In centuries to come, civilizations may learn to tap these resources on a larger scale, turning restless magma into an endless well of energy. What was once feared may become a source of survival, as people learn to live not just near volcanoes but with them. There is also the possibility that volcanoes may play a role in humanity's expansion beyond Earth. Understanding alien volcanism on moons like Io and Enceladus, or on planets like Mars and Venus, may teach us how to survive and adapt in other worlds. Perhaps future explorers will harness cryovolcanoes for water on icy moons, or seek shelter near ancient lava tubes on Mars. Our relationship with volcanoes may not end with Earth, but continue as we carry our curiosity into the wide solar system. The future of Earth and its volcanoes is therefore a story of continuity and change. They will continue to shape landscapes, influence climates, and test life's resilience. They will also remind us of the deep timescales on which the planet operates, far beyond the brief span of human history. To watch a volcano erupt today is to glimpse not only the past but also the future, a reminder that Earth's fire is still alive, still shaping the destiny of continents and species alike. In the end, volcanoes are not simply natural hazards or geological curiosities. They are expressions of Earth's inner life, signs that the planet is not dead but breathing, restless and creative. Their future is bound to the planet's, and through that bond, to ours. Long after cities have risen and fallen, long after civilizations have come and gone, volcanoes will continue their work, indifferent yet essential. They will build and destroy, warm and cool, challenge and sustain. They will write the future of Earth in fire, just as they have written its past. And so the story continues. Continents drifting like rafts, mountains rising and collapsing, skies dimming with ash and clearing again. Volcanoes will remain the patient architects of Earth's destiny, carving the chapters of a world still in motion. For all their violence, they are also symbols of resilience, proof that life and fire have always been intertwined. The future of Earth is the future of volcanoes, a tale of heat, stone and survival that will unfold long after we're gone. Volcanoes do not ask permission. They rise, they roar, they collapse, and they begin again, indifferent to the lives and landscapes around them. For much of human history, they have been cast as villains, destroyers of cities, darkeners of skies, authors of famine and fear. Yet as we trace their story across deep time, another picture emerges, one that is far gentler, even strangely comforting. Volcanoes are not just destroyers, they are creators. They are architects of oceans, sculptors of continents, chemists of the atmosphere, and gardeners of fertile soil. Without them, there would be no seas to sail, no air to breathe, no ground to farm, no myths to tell, and perhaps no life at all. When Earth was young, it was a world of fire. Molten rock churned across its surface, seas of lava glowed under a newborn sky, and eruptions were as common as storms. It was a hostile place, but hidden in the chaos lay generosity. Every plume of gas, every fountain of lava, was a delivery of ingredients. Carbon dioxide and nitrogen thickened the atmosphere, water vapour condensed into oceans, and minerals spilled into seas and soils. What appeared destructive was, in fact, the slow assembly of habitability. Out of fire came air and water, the twin necessities of life. Out of lava came the platforms on which forests would one day grow. As time unfolded, volcanoes did not step aside. They continued their work with patience, sculpting the surface of the planet into something recognizably alive. Under the seas, they built ridges that stitched the ocean floor together, ceaselessly producing new crust. At subduction zones, they raised mountains and islands, shaping the outline of continents. Even beneath glaciers, they whispered their presence, melting ice and reshaping valleys. Volcanoes became the hidden masons of geography, piling rock upon rock, ensuring that Earth was not a water world forever, but a planet with continents and coasts where life could flourish. They also gave more subtle gifts. Fresh volcanic rock, once broken down, became soil of astonishing richness. From Italy to Indonesia to Central America, civilizations have thrived in the shadows of volcanoes precisely because of this soil, dark and fertile, replenished every time fire visited the land. It is a paradox that still holds true today. The same mountain that may one day bury a village in ash also feeds the vineyards and rice fields that sustain it. For early humans, these gifts were too valuable to ignore. Obsidian for tools, basalt for grinding stones, fertile land for crops, volcanoes were not distant curiosities but daily companions, woven into survival itself. And of course, people did not only farm or chip stone in the shadows of fire, they told stories. How could they not? To see a mountain spew fire into the night sky was to glimpse the divine. Volcanoes became homes of gods and goddesses, forges of celestial blacksmiths, prisons of giants, or the beating hearts of restless spirits. In Hawaii, Pele-shaped islands with her lava flows. In Greece, Hephaestus hammered weapons beneath Mount Etna. In Japan, Fuji stood as a symbol of harmony and the sacred. Volcanoes entered myth not only as threats, but as beings of creation and power, mirrors of the mystery people saw in themselves. Yet the darker side of volcanoes was never forgotten. Pompeii, Krakatoa, Tambora, and countless other eruptions left scars across history. They toppled cities, triggered famines, and altered climates. At times, they seemed almost to reset the story of life itself. Mass extinctions linked to volcanic outpourings cleared the evolutionary slate, erasing dominant species and opening opportunities for new ones to rise. The age of the dinosaurs, the age of mammals, perhaps even the age of humans, were all influenced by volcanic catastrophes. Fire did not merely sustain life, it also redirected its course, sometimes brutally. And yet from those endings came beginnings. Out of the Siberian trap's devastation arose new ecosystems. Out of the shadow of Tambora's cooling came migrations, innovations, and even art. Life bent but did not break. Time and again, volcanoes reminded Earth's inhabitants of their vulnerability, but also of their resilience. To live with volcanoes is to live with cycles of loss and renewal, to accept that destruction and creation are inseparable parts of the same rhythm. Even now, in an age of satellites and seismographs, volcanoes retain their mystery. Scientists can measure their gases, map their swelling slopes, and listen to their subterranean tremors, yet prediction remains imperfect. Volcanoes erupt on their own schedule, reminding us that the planet is not a machine but a living system, one that speaks in a language of stone and fire we are only beginning to understand. There is humility in that. For all our knowledge, we remain guests on a restless planet. Looking outward, we see that volcanoes are not only Earth's story. Io erupts endlessly, painting itself anew with sulfur fountains. Mars holds the frozen monuments of ancient fire, Olympus Mons towering like a fossilized memory. Venus bakes under an atmosphere shaped by volcanic breath. Icy moons like Enceladus and Triton spout geysers of water and methane, cryovolcanoes that hint at oceans and the possibility of life beneath. Volcanism is a universal process, a cosmic way for worlds to express their heat and reshape themselves. Earth's volcanoes connect us not only to our past, but to the larger story of planets themselves. And what of the future? Volcanoes will continue their patient work. New islands will rise from the seas, continents will drift and collide, and super eruptions will one day dim skies again. Life, as it always has, will adapt, regrow, and flourish on the ashes. Perhaps humans will learn to live even more harmoniously with fire, drawing energy from its heat, studying its rhythms, and building wisely in its shadows. Or perhaps, like countless species before, humanity will one day be tested by the planet's fiery resets. Either way, volcanoes will endure. They will outlast cities and nations, outlast species, and perhaps outlast oceans themselves. What lingers most, though, is the realization that we are all, in a sense, accidental children of volcanoes. The carbon in our bodies, the nitrogen in our DNA, the oxygen we breathe, and the soil that feeds us all trace back to volcanic breath. The landscapes we inhabit, the myths we tell, and the history we inherit are built on their foundations. Every eruption, every plume of ash, every quiet emission of gas was part of the long experiment that made Earth what it is. To be alive is to be the outcome of billions of years of fire working its patient chemistry. There is something calming in that perspective. Volcanoes are not just disasters waiting to happen. They are reminders of the continuity between destruction and creation, between chaos and order. They remind us that even the fiercest forces can give rise to beauty, that life itself is the child of turmoil, and that we live in a world where endings are always beginnings in disguise. So the next time you see an image of glowing lava, or hear of a distant eruption, pause for a moment. Beneath the spectacle is a deeper truth. The oceans, the air, the continents, the forests, the harvests, and even your own breath are all threads in the tapestry volcanoes have been weaving for billions of years. We are not separate from them. We are their legacy. In the end, to reflect on volcanoes is to reflect on our place in the cosmos. We are fragile beings, yes, but also children of fire, living proof that creation can emerge from destruction. Earth itself is a story written in eruptions, and we are one of its latest chapters. The mountains still smoke, the ridges still spread, and the vents still breathe. The story is not finished. Volcanoes will continue to shape the Earth long after us, and perhaps that is their greatest lesson, that we are part of something vast, something that began in fire and will continue in fire long after our brief moment has passed. To live, to breathe, to be, is to belong to that story, We are, all of us, accidental children of volcanoes, and their fire still burns quietly beneath our feet.